Okay, hello everyone. Um, this has been a while since I've done a live stream. Last time, I think it's almost a year and a half or almost 2 years now, so I'm a little bit rusty. But please let me know in the comments, in the chat, if there is anything wrong, like anything wrong with the audio quality or the video quality. Um, yeah. And today we are going to try to code this whole self-driving car simulation live. So I'm going to go through the all the contents in the course. And I'm also going to try to add a little bit of extra functionality because some of you have voted that you're interested in seeing curved roads. I think I've got about 20 or more comments saying, how can we make that road curved? And I'm going to try to do that today. So thanks for all participating in the chat, and thank you for letting me know about the sound and video quality. So let's just see how this goes. Hopefully the quality stays up and hopefully the coding goes well. Hi everyone. Yeah, so let's start off as easy as possible. I'm going to try to go slow, and I have notes from when I recorded the videos from the course, so I'm going to try to follow those and make as few mistakes as possible. And yeah. Wish me luck. And I'm going to check from time to time the chat and see if there are questions from you. And I will try to make this session a bit more interactive if possible. So let's see. We begin with basic HTML. And let's have here a head section. And the title for the page is going to be, let's say, JavaScript self-driving car live, because this is a live session. So same contents as in the other course, but let's see how it goes in a live session. Yeah, well, good question there, Adib. I think the main reason why it's not so popular for machine learning is because it's speed. So it's slower than other languages. It also has limited resources because it's executed in a browser. So it's going to be slower than other things. And many machine learning systems need to be fast, especially self-driving cars, because you need to be able to make decisions quickly. The car needs to react quickly, as fast as possible, to things happening in traffic. So using a programming language like this one is not ideal for this case. All right, and we will need some CSS as well. Let's define our styles in style CSS. And that's all I'm gonna add in the head section for now. And the body section is going to have the canvas. I call it my canvas. This is where we will draw everything and make the animation and simulate everything. And let's add also the JavaScript file, the main JavaScript file. I'm going to write here script source is main.js. Let's close the script file. And I will close the body and the HTML page. So these two files here, the style CSS and the main JavaScript, I need to create them in Visual Studio Code, and I'm going to do that next. So let me type here style CSS, and I'm going to define here some styles for the page, because if I just refresh now, well, yeah, main.js is not found because we haven't defined that main.js file yet, but the elements are here. The canvas is here, it's just invisible at the moment, and I want to add some styles to make it visible so we see where we work, and remove this margin, this orange margin that the body comes by default in Chrome. So a little bit of styling here I think is important. I remove this margin, and let's just set the background of the body to dark gray. Hide the overflow so that these so that scroll bars won't appear, and align everything to center horizontally like this. And the canvas is going to be a shade lighter like this. All right, let's see if this has any effect. So now this canvas here is centered and it's a little bit different color. So yeah, I think this is good. Let's see what happens in the chat. No, we are not. So we are not going to do backpropagation for training the neural network, unfortunately. It's something that, in a way, it's not needed because the car was going just fine. So our scenarios are just weak enough, easy enough that we can train it by trial and error. And backpropagation is still something I couldn't figure out why, how to implement, because we need to know when a car does something good and when a car does something bad to affect it, the network. And I just still have trouble with that, but it's on my mind all the time. Yeah, live server extension could work, definitely. And I know it refreshes the page. The problem is that it refreshes too often. And I think that for teaching purposes, I want to have control over the refresh. So it's a personal preference. I think it's clearer for you guys if I don't use that. Yeah, okay. So this seems to work. Let's do also the main JavaScript file. I'm still getting the error here that main.js is missing. So let me create this main.js file. And inside of this, I'm going to set our canvas to be the same height as this window right there. So let's write here my canvas height is equal to window inner height, like this. And I'm gonna set the width to 200. That's how wide our road was in the course. Let me save this and refresh. And now we have that vertical road going. Well, it's not yet a road, but the shape of the canvas resembles that of a road. Physics videos, I might do someday. I will do math videos soon, more related to linear algebra and trigonometry, so wait for those. And yes, I will keep the live stream to watch later, so it will be a video available on my channel afterwards. Right, so let's begin to implement the car. This is nothing yet. And for that, I'm going to access the canvas context, get context 2D. Some of you guys made a 3D variants of this. It was really interesting to see on Discord. And let's pretend that we have this car object, and I'm going to define it at 100, 100. So this is XY coordinates, And let's give it a width of 30 pixels and a height of 50 pixels. So this car object is something that we don't have yet. I'm going to have to implement it, but I want to draw it on the context when it's ready using the canvas context. So let me now define this car. I'm going to create a new JavaScript file, car.js. And here we are going to define the car using a class. So we use this syntax. And class car and the constructor. So in the constructor, we already expect a x, y coordinate and the width and the height, the ones that I've wrote in main.js. So x, y, and then a width and a height like this. And I will set these values as attributes of the car. So the car will have an x attribute and it's going to be set to whatever the value coming from here is. So 100 in this case. And then the same will happen for the y. The same will happen for the width. And the same will happen for the height, like this. Yeah, generating traffic dynamically is not very complicated, I think, but yeah, some people on Discord did it already. But I think generating too much traffic can be a problem because we didn't optimize things like collision detection or the sensors detecting all the cars. So if you add too many of them, then you might have a problem with it being lagging. There are many improvements that we could do to this code, and I will speak about the extensions to this course a bit later today. So stay tuned. But now here in the main, we define the car and we draw it. So we need to define this draw method, which takes the context as a parameter. And let's just begin the path. So these methods are part of the Canvas API. And I'm going to draw a rectangle from, let's consider this XY to be the center of the car. So if we want to draw a rectangle around this XY center of the car, we will say here this X minus this width divided by 2. And then for the Y, the same but with the height. And then the width of the rectangle and the height of the rectangle. So these 4 parameters are what can be sent to this rect method of the canvas context. And let's fill this rectangle. So it's going to be a filled rectangle, black rectangle. By default, the color is black. All right, so let's save this and refresh the page. Aha, car is not defined. I forgot to include it here in the HTML file. So let me do that. And there it is. So if this canvas here is 200 in width, and I'm drawing the car at 100, I really have to remind you that this here is the 0, 0 coordinate. So 100 on the x-axis means halfway like this, and 100 on the y-axis means 100 like that. So our car of 30 pixels wide and 50 pixels high is drawn centered in this canvas, but somewhere on the top part right here. Okay, let me look at the chat again real quick. Nothing new, I think. So we need to control this car somehow. And of course, eventually it's going to control itself. That's going to be the whole idea of this course. But to start off, we will control it ourselves using the keyboard. And I'm going to go here and create a new file for controls like this. And let's implement these using a class again. So the constructor is not going to take any parameters this time, but we will have some attributes inside of this class that I will set to false. So one attribute for the forward direction, if we are expecting the car to go forward or not. Another attribute for left. Another attribute for right. And another attribute for reverse. All of these are false to begin with. We assume that people are refreshing the page, going to the web page without anything pressed on the keyboard. And now I'm going to add so-called keyboard listeners, which means that we detect what keys are pressed by the user. So I'm going to define this in a private function, and this function will be starting with a hashtag because it's a private function, and it will be called add keyboard listeners, like this. And it's not actually a function, I misused the term. It's a so-called method because this is object-oriented programming, and functions that are part of objects, they are referred to as methods. So let's implement here our private method. And some of you have been asking me, why is this method private? I mean, why am I using this hashtag right here? And really, it's just because I don't want to provide access outside of this object to this method. So if you think about our car class, this draw method is not private. It doesn't have this hashtag. And it's for a reason like that, because I am calling it here in the main JS file. But this function right here, it's just called when the controls are initialized, and it's called by the controls itself. So there's no need to provide external access to this. And it just explains to the people reading the code that this function shouldn't be called from outside. So it's a good coding practice, really. It's the only reason. Code will work just as well if you make it a public method. So a document, and we detect the on key down. And I'm using here an arrow function notation. So I'm not using many arrow function notations in this course for defining functions, but here I did have a reason for it because I wanted to refer to the object itself using this. And if you use typical function notation, then this will start referring to the function itself instead of the parent, like in this case, the object, the controls object. So I'm writing it using an arrow function, and I do a switch here depending on the key that is pressed. So in case this is the arrow left key, then I'm setting the left attribute to true, and I will break. So switch case requires a break here if I want to exit and not continue to the next case. So the same thing happens for arrow right with the right attribute. And the same thing happens for arrow up with the up forward attribute. And the same thing happens with arrow down and the reverse attribute like this. Let's break. And I'm gonna close the switch. Let me scroll down a little bit. And let me log here the controls, or this in this case, so that we see if this code is working or not. So I'm closing all the curly braces here and refreshing the page. Now I'm pressing the keys, but nothing happens. And I've gotten this remark from some of you. It's because we need to first click on the page, but this doesn't work. Wait a second. Oh, I'm not initializing these controls anywhere. So I have to go to the car, and I need to define the controls here. I set them as an attribute. I think this is what I did in the tutorial. Is equal to new controls. And let's try to refresh this. Okay, and controls is not defined. This is because I forgot to include the new file here as well. Okay, so something works here. I'm getting the table log just fine in the console from this. So what happens here is depending on what keys I am pressing. So now I'm pressing the forward, the up key, the up arrow key. Now I'm pressing the left also. Now I'm pressing the right. And now I'm pressing the down arrow key. Some of you have replaced these arrow keys with ASDW, like in many games, like shooter games or whatever. That's perfectly fine. It's a nice change. Some of you even have supported both ways of doing this when you have followed along and made your own updates. So those are even better. And I think one person has even made it so you can select this in a separate panel. I don't remember if this is from Discord or YouTube comments, or maybe even some of my students here at work, but that was quite nice. So you could select what controls are which. Really neat. Right, but now I need to detect when I release a key as well. So I don't need this debugging here anymore. I can see that it works. And I'm just going to copy this key down event listener with the key up event listener instead. And I'm going to set everything to false. So now when I release each of the keys, these controls will be set to false. Some other question. PhD or company? Well, that's a very interesting one. Well, I did a PhD, and I did the PhD because I was offered the opportunity to do the PhD. I got pretty much a 4-year contract, and I was paid to do the PhD. I didn't have to worry about money, and that's not true for everybody. It's not easy to get these paid positions. And if you do go for that, then the money will be less than if you go to a company. Companies pay quite well. it really depends on you. What do you want to get? You will get experience when doing PhD. You will get experience when joining a company. You have more free time when you do the PhD. Well, it depends again about you, but you have more flexible time, so to speak. Like if tomorrow you don't want to go to office and you want to do something else, if there's no teaching or meetings involved, then you have the freedom to do that. And mm, people don't really check on you. So as long as you're meeting your deadlines, you have that kind of flexibility. In a company, it's much less. And of course, the holiday times are shorter as well. So yeah, those are some kind of benefits. PhD gives you a lot of skills, I think, mm, especially time management skills. If you go to a company, then you are told what to do and when the deadline is, and you have to meet that deadline. But in the PhD, you have to somehow figure out your deadlines for yourself and maybe for other students if you work in a team. So you're learning many valuable things that could be useful also as a CEO later if you start a company or yeah. So really hard to say what you value more. Do you want to get experience of coding in industry? Do you want to code in industry? I tried both. I was at Microsoft for some time and it was nice, but um, somehow I like teaching more. I think that teaching is something that I like doing, and it's my own preference. Mm, yeah, it's hard to say. Everyone is different, and money somehow has not been a motivating factor for me. Like I I don't care so much about it as long as I can live and do my things. So yeah. All right. Oh, yeah. Thanks, Samuel, for sharing the Discord link there. And there is a Discord. I don't check it all the time, but I've seen that many people help you with exercises if you try to follow along and you have issues. So it's not necessarily me that is helping you, might be somebody else. Mm, but it's I might change the way I approach things in this Discord channel someday. I think the channel has been growing and it has been growing somehow in a way that I'm not prepared to face its consequences. So uh, I'm taking my time. Yeah. Well, these kind of advice topics, I used to have a series where I give advice to students, and I think they were liked, but I had to discontinue it because I was doing these advice videos while walking outside or running or whatever. It was this walk and talk playlist, and then I broke my leg, so I had to stop giving advice, and now I guess I do it during the live stream to take a break. Yeah, well, Microsoft was also nice, and the team was very skilled, and I learned many things like project management skills from there. Um, it was just not the kind of thing that I preferred. Um, I have a small child at home, and somehow when you do very hard things, very serious things like research or you have to meet deadlines, then somehow they bother you afterwards, and you cannot be yourself at home if you have something bothering you. So that's also some a decision I had to take in that time. We are all different, and money is just one thing. So yeah. Interesting question. Why you don't need to call something like document query selector, my canvas? Well, the reason is that all these IDs that are being defined here, they by default become global variables in JavaScript. So actually, if you type here in the console my canvas like this, you have direct reference to the canvas element in the DOM, in the HTML DOM. This is something that happens by default. And yes, if you do here something like document get element by ID my canvas or the query selector, then you will get the same thing here. And I actually recommend that you do this, because I could have started the JavaScript file with defining something here like const my canvas is equal to some other canvas. And then I'm essentially overwriting the value of this global variable. And I don't recommend to do what I've done here. I essentially skipped the step. But good point, good question. And for small projects like this, believe it or not, this is a very small project. Doing this is just fine. But it may have some strange effects if you consider this overriding possibility. So it may be that these global variables from here become something else in your code when you write more JavaScript. So keep that in mind. Okay, let's go on. So here we want the car to update depending on these controls, on what the controls are telling it to do. So I'm going to go here and write an update method. And let's begin like in the tutorial. If the controls forward is set to true, we don't need to write here is equal to true, because if statements work like that, we can just put here the value of forward. And then we can change this y coordinate of the car by going upwards. Now remember, upwards is the negative direction of the y-axis, so we have to subtract the value, let's say 2, and I will repeat this, making the car go downwards on reverse, like so. Now inside of main, we need to run an animation loop here, because at the moment we are just drawing the car and then the program is over. But we need to draw this car again and again and again on every frame so that it will update its position depending on what we do with the controls. So I'm going to start an animate loop here. I call an animate function, and let's define the animate function here like so. We will update the car on each frame. So when we call this update here, it's not going to do anything if the controls are not pressed. But if they are, these y values are going to change. And here I have to point out something really important. In the video course, in the tutorial, many of you missed this step. I moved this car.draw ctx inside here. What you guys did is you wrote car.draw ctx here, and you had one previously at the top, and at the moment there would be no problem. But later on, this caused an issue when working with the sensors. So this was probably one of the most asked questions. Why is my code not working? It's because you missed this step. And you missed this step because in the video tutorial, I went through it really quickly. Like somehow I didn't think I should emphasize that. And now I am doing it. So sorry. And to have the animate loop here, I'm going to type in request animation frame and pass the animate function to request animation frame which is going to call the animate function many times per second, as much as 60 frames per second if possible. Okay, so refreshing this, and now if I press up and down, something weird happens. It's not moving, seemingly is not moving, it's just making this line, but that's because this canvas is like what a painter would use when drawing on a canvas. So it paints a rectangle, and then when the rectangle goes up or down, depending on these controls that I'm pressing, it paints it again and again and again at the new positions, like on top of each other. So if we don't do anything here, like how to say, we don't clear the canvas in some way, then this is going to not move the car, but leave this kind of streak behind it. So this way that I used to move the car is also a little bit controversial. I did this here. I wrote my canvas.height is equal to window inner height inside of the animate function. And I did that because if you see here, when I resize this window, the height of the canvas, I would like it to stretch to the size of the window as I'm resizing it. So if I refresh the page now, and I do this resizing, it works. It's happening 60 times per second. So as I am moving this, pretty much immediately the height of the canvas is set to the window inner height. But there's more. There is a thing when you reset the size of the canvas like this. So now it happens on every frame. It resets the canvas properties as well. So essentially, what was previously on the canvas has been reset, and the car from the previous frame is not there anymore. So this line of code made two things happen at once. And normally I don't do this. Normally I use something like the clear rect method of the canvas context, and that is clearly doing the cleanup for me before each frame. And this effect that the canvas resets itself on resize is in a sense doing that for me, but it's not totally clear. So some of you had a little bit doubts about this, and I have so too. Usually I have two things here, on resize event listener and a clear rect, and then the code is really clear. But here I wanted to not focus on all the details, and somehow I wanted the code to be as short as possible because it is a lengthy project. So I was okay with this solution. Okay. Let's see what the chat says. I don't know TypeScript. I have never typed any TypeScript. And JavaScript has not really been my main language, really. It's a recent thing since I started doing YouTube. Mostly I've been coding in Java, PHP. At Microsoft we used C#. And those are more robust languages. But for these small projects, JavaScript is somehow all I need. And I think TypeScript has its uses when you build really big applications. But apart from this self-driving car and maybe a few other projects I built on the channel, like the Puzzle Cam, or I don't know what else is a big course like this with the actual project. Apart from those, they are relatively small things. And I don't think that JavaScript is so bad if the project you're building is small. And when the project size grows, then I think TypeScript would make sense. I know what it is, I just never used it, and I find it overkill for these small things I'm teaching you. Yeah. hmm Okay. So, yeah, the car moves now up and down, but this is not really how cars move. So I would like to give this car something like a speed and an acceleration. So the acceleration is the thing that changes when I'm gonna press the forward button. So let me go here in the car and and let's define here speed is equal to 0, and let's give it acceleration value, like acceleration is equal to 0.2. So this will be how much we accelerate or decelerate depending um, on what the controls are telling us. So here, instead of changing the y value directly, I'm going to remove this code and say this dot speed plus equals acceleration. I want it to accelerate when I'm pressing the up arrow key. And of course, I want it to do the same thing here, but with a minus. And let's test. So if I'm going to test now and I press down, okay, it doesn't work. So I forgot that I need to update the y value as well. So now the y is never changing. It's just these attributes that are changing. Like if I type here car speed, it has a value 14 something. And if I press now down a few more times and I check it again, it's minus 19 something. So it's changing, but it's not affecting the y value. So this dot y, I'm gonna say minus equals this dot speed, because again the y goes downwards. So now it's going down, and I let go of the keys and it's still going down. And now I'm pressing up a few times and hopefully, oh boy, boy. Okay, up and down. I'm just pressing up and down, trying to control this car a little bit. So it's kind of like sliding on ice. After it gets an acceleration and the speed has been set to a certain value, it continues to go there forever because there's no friction involved. Also, the speed can increase forever, essentially. So we need to cap that as well. So I'm going to go here and say this max speed is equal to 3. We give it a value for the maximum speed and a value for the friction here. A small value that will decrease the speed on every frame depending on if we don't, I mean, if the controls are not accelerating the car, then it will slowly decrease its speed towards 0. So now let's use this here. I'm going to say if the speed is greater than the max speed, which is something that we don't want, I'm going to set it to be equal to max speed. I also want to do this for going in reverse. So I'm using this trick where a negative speed means going in reverse, even though there's no such thing as a negative speed. It's just a speed, but in another direction. Some of you have tried here to re-implement my code using vectors instead. So there was a little bit of a discussion with some guys about what is velocity and what is speed. So velocity is a vector. It has a magnitude, a size that is the speed, but it also has the angle component. So velocity is a combination of the angle in which it is going and also okay, I can't see my stream anymore. Somehow this computer shut down on me. Just a second. And that's probably a better way of implementing it. But I didn't want, okay, I'm back on. One computer that I use to see the stream is shutting down by itself. So yeah, that implementation would be better, but it's longer and I would have to teach you about linear algebra, and some people are scared about vectors, so I use this trick instead. So I also have a condition here when going backwards. If the speed is less than half the max speed, but with the minus in front, I want to cap the reverse speed earlier so that we can't go really fast in reverse. It's just how cars work. Then I'm gonna set the speed equal to minus half the max speed value. So this is not great. If you're a physicist, you will probably say I did very many bad things here, defining a speed as negative. It's just a small trick to avoid writing a lot of code and talking about vectors and angular velocity. Of course, you can expand each of the components of this code individually. So you can make the physics better, you can make the sensors better, you can make the neural network better. Everything can be improved. But I wanted to have a minimal system that looks good enough, acts good enough, and somehow goes through all the elements of building an artificial intelligence. So let's implement the friction as well. So if the speed is greater than something, than 0, I'm going to decrease it slightly. So friction is going to affect all the time. And I have to also write here the opposite part. Like if we are going backwards, so the negative speed, then I'm adding the friction instead. Okay, so now we have something here, and I'm going to refresh. I press down and it's picking up speed, but when I lift my hands, it eventually stops. And for front, same thing, but it goes a little bit further and a little bit faster this time. Yes, the course has been already posted on YouTube. It's on my channel. It's also on the Free Code Camp channel. So you will know most of these things here. Oh, actually, Samuel is explaining these things already. Thanks. Yeah. I will try to explain it a bit more. Let's see if I do a good job. So we get to that soon. But now this seems to work, and there is only one small glitch that can happen. I'm gonna try to reproduce it. I don't know if I can reproduce it, but I did it, yes. So if I have a specific speed, I'm going at a specific speed, and I'm letting go of the up arrow. So this happens. The car is actually moving now. It's moving very slowly, and I don't have anything pressed anymore. It should be stopped. But the thing is, it's going to be less than 0, but also less than friction. So it happened that it's less than friction. So when it's going to be less than 0 after this speed here is made, sorry, the speed is, yeah, less than friction. So then when I subtract this friction, it becomes also less than friction, but on the negative axis. So then it's less than 0, and we're going to add friction again, jumping it back forward. So after these two things, the speed is a little bit less than friction on a positive scale. So it never really becomes 0. And this is a kind of a glitch that I just don't like. And I'm going to fix it by saying that if the absolute value of the speed is less than friction, then just make the speed 0. Yeah, so let me zoom out again. And now it should never happen, and I've never seen it happening after this change. So no name is mentioning sine, cosine. These are things that we are going to move towards next. So the left and right keys, the left and right controls need to be considered. And let's define an arrow, an angle component here. This angle is 0. My keyboard layout changed. Okay. So this angle is 0. And for the controls, if we go forward and reverse, this affects the speed. But if we are going to press the left arrows and right arrows, then this angle is going to increase by a small value. And if we press right, this angle is going to decrease by a small value. Now, left rotation is going to increase the angle because commonly you refer to angles increasing counterclockwise if you think about the unit circle. So this is typically how the unit circle is drawn, and this is here a positive value for this alpha, because on the right here, if it would be touching this axis, then that's a 0. Positive values go up, and these values here could be interpreted as negative values, or this positive just goes all the way to 2 pi radians or 360 degrees. So negative values here, or really large ones after going around the whole circle. So yeah, I keep this idea of increasing the angle like this or decreasing the angle like this. So if your car is facing towards the right, increasing the angle with the left arrow and decreasing the angle with the right arrow. That's somehow the logic. It's kind of not great. So no name there is making a valid point that I think the logic here could have been better. But let's try it out. So to draw the car at a different angle, I'm actually going to do a trick here. And I'm going to save the state of the canvas and translate it to the car's location, X and Y. And then I will rotate by minus this angle right here. And then here I really don't need to do some things like this translation here is already done, so I can remove the X and Y elements from there. And I need to restore the canvas context like this. So let's refresh this, and pressing the left arrow is increasing the angle, but here this rotation is doing with the minus angle. So this is how the code was written there. It becomes a little bit more complicated next. So I will try to simplify it a little bit and explain it better. Maybe not simplify it, but explain this unit circle thing better. Let's explain it by setting the car oriented in a way that is actually according to the unit circle. Maybe changing the width and the height here. So now the car, let's pretend that it's going towards the right, in the same way that this zero angle would go towards the right on this unit circle. So in this case, left and right do these moves. So yes, it's working as expected. But now we want to move the car's X and Y location according to this angle and the speed. So how do we do that? Well, we can go here and type something like this X, we add to it the value of the cosine of the angle. So this is going to be a little bit different than in the code in the course, because this is defined exactly according to the unit circle definition, but yeah, but yeah, just a second. So up and down are moving it that way now, and left is going like that. So it is working. Now this is exactly according to the unit circle definition. So cosine of an angle is defined as that distance on the horizontal axis. So here x increases by the cosine of the angle. It just means that whatever the angle is, the horizontal component is going to be scaled by the speed. So cosine just means the horizontal component. And this is a unit circle. So in this case, this arrow here is 1. So we need to scale this by the speed. And the y value is the sine. So the sine of this is the vertical component, but I'm using minus here because this is because the y-axis goes downwards on the computer screen. So this would be maybe a simpler implementation than the one we had in the course. And of course, we could have now rotated the car, like maybe set here the angle to minus math.pi divided by 2. And what this will do is we rotate the car like that from the default orientation like this. And okay, it doesn't work. It should be plus pi, I think, because we are doing here this negative angle thing. Let me, yeah. So this could have been done in the course, and maybe it would have been clearer. I don't know, but I'm going to revert back to the same code that I used in the course, just because I want to have some consistency here with that code base. So it might be a bad idea, but I think doing it like this is okay. So in the course, what I did is I didn't use this unit circle as the reference. I used a kind of a rotated unit circle, and you also have to consider that the y grows downwards. So this kind of mental math is somehow, it's in a sense easy for me to do, but it could be complicated if you are not very good with trigonometry. The good news is I'm now working on some videos that I want to teach you trigonometry with, and I believe that these things will become much clearer then. So in the course I had here, because of this change here, the x is controlled by sine, and the y is controlled by the cosine. I believe it was like this. And the car was already defined to be 30 width and 50 height. So no, it's not going well. I don't remember anymore how it was in the course. So the angle here is 0 like that. It might have been like this. I really don't know. I don't remember anymore how it was. So rotation like this works, but it goes opposite direction. Let me see. Okay, sine increases like this, so I think that this might be minus here. Yeah, probably this is how it was. So sorry for this becoming a little bit confusing in the tutorial, and I tried now to show different variants of this, but yeah, I'll try to clean it up in future tutorials, this explanation. It's not very good. And I will have this video where I teach trigonometry, so stay tuned for that. Maybe even soon, maybe by the end of the year. So, one thing I still don't like about this is that if I'm going backwards and I'm pressing left, so turning the steering wheel to the left, the car should turn somehow like that. And now it's doing exactly the opposite. So I have implemented this. Where did I implement this? I think I had this flip constant. Yes. So. I don't remember exactly how I did this, but let's just try it. So if the speed is not 0, I define a flip value equal to 1 or minus 1. So depending on the speed, if it's greater than 0, I don't need to do this flip. Otherwise, I do this flip. And this is going to be now affecting our code here by just multiplying it with the flip. So the reason this works is that this sign essentially is turned into a plus if the flip is happening. Yeah, let's see if this works. No, it doesn't work. The flip should be added to this angle, I think, because no, I don't really remember. Don't remember, and it's kind of hard to concentrate too much on it. Anybody remembers how this was done? I could look at the code, but yeah, let me look at the code. I don't remember, and when I try to do these variations, then mhm. So quick check here in the car. Oh, it was when we changed the angle in the controls. Yes, I made a mistake. So not here. This part was just normal like that. And when changing the angle here with left and right, this is where the flip was added, of course, because we want the angle to be changing sign in this case. Right, so now going down and left, it goes as I prefer it to go. And up is also good. So now this feels to me like actually driving some kind of car in a game. Yeah, all right. So I'm happy with this movement. And next I move on to drawing the road. Yeah, there will be some new things. This experiment here is a new thing, but I don't know if it clarified it really, because I made some mistakes. But there will be something I will try to implement curved roads as well. So let me next start to implement the road. So road.js, we define a new file. We implement this road in a new file. We include the road.js file, and I'm going to implement this using a class. So road, and in the constructor I will position the center of the road at x and give this road a width like so. So let's set the x attribute of the road to x and the width of the road to the width parameter. And I also had in the tutorial this lane count because I wanted to display the road using the dotted lines on the middle screens. Yeah, minimap someday, but not today. So I do have a plan for this. I will tell you soon. And this lane count, actually, let me just define it here as a third parameter with a default value, let's say 3 lanes to begin with. And let's define also some helper attributes here. So one for the left is equal to x minus half the width, and one for the right is x plus half the width. So again, center of the road is the x coordinate, and then half the width to the left and to the right. It's somehow easy to implement in this way. And this is also maybe one of the biggest things that you guys had an issue with, the constant for infinity that I've used. So I just put here a number of zeros, but I wasn't very specific when adding it there. And it turns out that if you use a too big value, the system breaks. Now I'll show you, but let's first say that the top of the road is at minus infinity and the bottom of the road is at plus infinity. Remember, x and y goes downwards. So let's just draw this real quick. So a draw method here. Given the context, I will set a line width of 5, a white stroke, and I begin path move to the left top. So these are really useful. Otherwise, many people do the calculation inside of this, and then you have a very, very long, long, how to say, function call. It's horrible. So I recommend having these helper variables. And the line is going to be on the left side from the top to the bottom, like this. And we stroke. I'm going to copy this for the right. And here, close these like so. Now, this road needs to be defined somewhere, and I'm gonna do that in the main file, somewhere here. The road. So the reason why I'm putting it there is actually because the car will eventually be declared so that it knows where the road is or something like that. I have to see my notes later on because the car will interact with the road. So I want this road to be existing before the car exists, if that makes sense. It's a small thing, but if you put it later, then it makes the tutorial a little bit more complicated. Like I would have had to change some things afterwards. So anyway, we defined a new road at the center of the canvas. So the width of the canvas divided by 2, like this. And I'm going to put it also have a width of the full canvas width, like this. So now I think this should work already. But no, I need to also draw the road before drawing the car. So road draw CTX here. And this probably works. Yeah, it works a little bit, these white lines here appearing on the sides of the road there. But if you make the width here smaller, I made it 0.9 in the tutorial, then you can see these sides of the road, kind of like the white sides of the road, like where you shouldn't be driving, like away from those. If I go cycling, I typically go in this section. So yeah, and let me define also these the lanes. Yeah, so for the lanes, here when we are drawing the left and rightmost part, I'm going to use linear interpolation to have evenly spaced x positions, and we are going to draw these vertical lines using a for loop. So I'm going to say here something like for I going from 0 to lane count, let's get this x value for each of these iterations depending on I and the lane count. So x is going to be equal to this lerp or linear interpolation. I've made a new video on linear interpolation because some of you said this is a complicated technique and that you want to see it. So I have a recent video on linear interpolation if you're interested. The function is really easy. It just expects here a parameter for the left side of the interval and then the right side of the interval, and then a percent value, um, like a fractional value between 0 and 1. So here I'm just using I divided by the lane count. So yeah, now this code right here is going to be so that instead of having the left here, I replace it with this X value. And actually, I don't need this piece of code right here. It's the same. It's a duplicated code. Now this for loop is going to do everything for us. But this lerp function, this linear interpolation, this is something that we need to define. So it's a simple, very simple function starting with A, B, and T. So A is for the start value, B is for the end value, and T is for this fractional value between 0 and 1. So here we have return A plus the difference between B and A multiplied by T. So this should actually work now. Because we have a lane count of 3 here, it looks like that. If we put here, for example, this lane count to something different, like maybe 5, then it looks like that. We have 5 lanes, kind of like a highway. So this is customizable and seems to work just fine. But this lerp function doesn't belong here. This is a utility function. It's something that we are going to be using many times in this tutorial, so I will put it in a utils.js file instead. And let me remember to include this utils as well. So this still works now. My streaming computer has shut down again. Okay. Right. So the lines in the middle should be dashed. So that's the one thing I still want to do next. And I did this by going here and checking the value of I. So if I is 0 or the lane count, then there is no dash. But if it's greater than 0 and less than this lane count, I set this line dash to 2020. So 20 pixels of line, 20 pixels of spacing there. And let's have a look at the chat. Okay. Oh, some people from Romania there. And greetings. Salut. So this mini map, I've seen it already previously. And some thank you messages. Yeah. Okay, great. And I guess those are some kind of donations. I really don't know how this YouTube system works, to be honest. And thank you for those. But you don't really have to. So it's just fine. All right. Then here, the line dash should be nothing there in that case. So how does this look like next? Well, if I'm going to refresh this, I'm going to see these middle lanes with the dash. And that's what you guys weren't getting with this infinity set too high up. So there is a bug in the, not really a bug, but somehow the functionality of this drawing the line dashes breaks down if this infinity constant is too large. And it's actually the reason why I didn't use here something like number max safe integer or something, because this is a really, really big number and it would have broken the system. So I consider this a bug, but normally you don't draw roads that are this long. Things that are roads that are procedurally generated like this typically generate only the section that you are interested in, the one close to the car. It's like that saying that if a tree falls in a forest but there's nobody there to witness it, does it make a sound? That's what typically happens when you render these simulations. You don't render something far away. In this case, infinity is maybe not the great choice there. But yeah, let's continue here. And what I did find useful in that tutorial, and I wanted to teach you, is that you can have a method here for getting the lane center so that you put the car on the lane that you want. So given the lane index like this, you could put the car on that given lane in the beginning when we defined the car. This is actually why we want the road to exist before the car, because we want to put the car on the road on a given lane, so the road should be there already. So going back here, this getLaneCenter method, let's have a helper variable for the line width. Okay, I think, is this correct? Yeah, I think this is correct. So we take the width and divide it by the lane count, because in this case we have a new width, a small width, exactly how wide each of the lanes is. And now I'm going to return from the left the offset of half the width. So I want the car in the middle of the lanes, and then this lane index times line width. So yeah, this should work. It's not rocket science. So the reason I wrote this code like this is because I want the offset to happen here depending on the width, but also another offset by half the, not the line width, the lane width. This is not okay. When I'm copying now the code, I should really maybe improve it a little bit. So, or maybe my notes here are not the same way that I did the tutorial. It could be that these notes were done before recording, and then while recording I made a little bit variation. So I haven't looked at these for like almost a year now, so I'm a bit out of practice. Okay, so this getLaneCenter function here, we can use in the main.js file where we are defining this car. And instead of putting it at 100x here, we can put it at like road.getLaneCenter of 0, for example. So if I refresh this, it's on the lane with index 0 here. So there is also a lane with index 1, the second one, and the third one, the third one is with 2 here. So 0, 1, 2, the index on which lane we want to put the car. And I was showing you also that you could actually put it here as well on lane 3. So now the car is somewhere there. If I drive it a little bit, it's gonna come in the scene. So this is something that I don't like very much. So I would like this function to take care of these situations. So here where we have this lane index, we could put it so that we have the minimum between the lane index and lane count -1. So if we give it a value like that, that is greater than the possible lanes that we support, it's just gonna move it one before. So it makes it less less have a value. All right. So back here, I prefer to keep the car in the middle lane like this, as it was in the beginning, but now I just have more control over this. And one thing that we need is to start thinking about these collisions. Like, we make it so that the car hits these lines, these borders of the road. And for collision detection, I will have to implement something later, but preparing for these, we could define here the borders, these variables. So I'm going to set here the attribute for the borders, and I'm using here this array syntax. So the borders here are going to be an array of arrays, and I will edit this soon to have support for curves as well, because you asked for it. So a border starting in top left and going to bottom left, and top right, bottom right, like this. These are things that we need to implement. So top left, I just prefer to have a helper variable here, and it's going to be the x is coming from the left and the y is coming from the top, the previous helper variables. And this is really going to be same thing for bottom left, top right, bottom right. So I think I just copied these like so. I normally try to type as much as possible and less copy paste, but because it's somehow easier to follow, but sometimes I just don't have patience. So we could have here the border going from top left to bottom left. Now it's just 2 points defining this one border, this first border here. But this is the place that I'm going to soon modify to add a few more points and curve this road in a little bit. This was probably the most called for request, so I'm going to have to do it. I hope it's gonna go well. I didn't practice it. So I expect surprises to happen. But yeah, so now here in the drawing of the road, we could put the code to use these borders instead, because they are already defined so that we use them later in the collision detection. So might as well use them when we draw the borders as well. So here we could modify this code to start at 1 and then end here at -1, like this, and only do the line dashes at this stage. So at the moment, I am not drawing anymore this first one and the last one, and this design part is here with the line dash like so. But I could do a loop through these borders here, and let me do that like in the tutorial using this for each loop. So I've been scolded by some of you guys about not using enough for each. So I should. When you really want to go through all the elements in the array like this, then you can use a for each, and it's a little bit clearer because you get here the variable name of each individual border, and you can work with its properties. So here, the first point of this border, and it's x, and then the second, the y component of the first point in the border. And the second point of the border and X, and the second point of the border and Y, like this. So this is now drawing the borders a little bit differently. And let me refresh this page. No, it doesn't work. Why doesn't it work? So I'm going through the borders, I'm beginning a path, moving. So this is the first border and of 0 and then X. Let's debug borders. Oh, road borders. Okay, few mistakes here. I forgot the bottom. Top, bottom, top, bottom, and these are the right. So now it didn't work because these were all of them were top left, top left, top left, top left. So it was just drawing one point at infinity somewhere very, very high up. Let me refresh this. And now it works, but I don't want to have this line dash anymore when drawing the borders. So I'm going to reset it here, like so. Okay, so now the road is there. And one thing that I want to do is that trick where we make the camera follow the car. So this should be quite easy. Here in main.js, I'm going to after the updates. Okay, since this is changing drawing also that, let me put it down here. So updates don't draw anything, all these things here draw. I'm going to say save the canvas context, translate the canvas context to the by the negative value of the y, so I'm centering it on the car, essentially just vertically, and then here restore this context like this. And I have something to talk about here as well. So the car is here now centered, and if I'm pressing up and down, you can see it always is centered. It's not the thing that is going up and down anymore. It's this road, and it's a nice little trick. I do want to see the car, so in the tutorial I've added here something like my canvas height, and I multiplied it by 5. No, by something more like 7.7. So 70% of the canvas height, and now we can see better ahead of the car. This is one thing that actually doesn't need save and restore here, I think. And some of you have pointed that out. The reason why this code works and it doesn't make this kind of nested translations in it is because of this line right here, which really resets everything about the canvas anyway. So this is one simplification that you could do in my original code base. Okay, let me see some chat comments. Yes, Samuel, kind people giving me money. I really appreciate these things. But I'm doing these things because I want to. It's not something that I do for money. So thank you. And yeah. So then something like Python. Well, I am still tuning the Python course at the moment. I have a version of it, so I'm just using this canvas of Python, and I'm mm, not using libraries there as well to some extent. I'm using this tkinter library for the canvas. The canvas is there in it, and then at some point at the end, I'm actually using this neat library for doing the neuroevolution. So this is based on the research paper that I pointed in the tutorial on YouTube. It has much more options and ways to change the topology of the road network as well, like the number of hidden layers and the number of nodes on each of the layers. So those things are fun to play with, but more difficult to understand, and definitely more difficult to explain in a, let's call it a lightweight tutorial like this. So yeah, thanks, Jack person. So you saw this issue before I saw the issue, and I should check this chat more often, but it's a little bit blocked by my screen here. And also I'm concentrating on reading notes, implementing and fixing some stuff that I don't do properly. Right. Now, the borders. So let me try to implement these borders as a curved line. I really have doubts about what I'm gonna do here. I definitely want to simplify this and not use the dashes in the middle. So our car, the road here is not gonna have those details there because it will take too much time. And I'm also not going to consider making the other cars in traffic follow those borders. Sorry if that's like too little from me today, but I have a little bit of um, concerns even with just considering the borders, the curved borders for us alone. So I really don't know what's going to come out of this. So how would we do this? Well, we start off the borders with just the top left and the top right things here. The points in the top left and the top right of the borders, so the top side of them. And then at some point close to the 0 point, or actually a little bit more than the 0 point, I'm going to use a sign function. So it's going to be a sign because the sign of 0 is 0, and I want that curve to start happening there. So the road is going to go from the top until somewhere in front of our car, and then start to do some sine waves there, and then continue until the end. But after these, I need to add some more points here. So these points are going to define that curve. And in this tutorial, in this video today, I'm just going to use a simple sine curve. But here is where I have news for you. I'm planning the second part of this tutorial, and it's taking longer than I expected. But by the end of this second part of this tutorial, the car is going to drive on roads. It's going to drive in a road network, and it's actually going to drive on a road network wherever you want in the world. I mean, we are going to use data from OpenStreetMap, and you can put the car to drive in your own neighborhood. I also plan to have a little bit smarter AIs for the other cars and have them work on these roads as well. So second part of this course is not going to focus too much on the neural networks. It will check a little bit some other fitness functions, but it will focus more on the virtual world. So I think that's what I'm going to call this course, self-driving car JavaScript virtual world or something like this. So we will have the car having to deal with intersections, roundabouts, maybe even traffic lights. Let's see. So I want to make the simulation a little bit more realistic, because then there is a reason to experiment more with advanced neural networks. So this could be on a further extension to the course, or maybe this extra work with neural networks will come during this second part already. I'm not sure. But I want this to look somehow nice, to see there roads that look like real roads. And yeah, I'm just focusing on making the visualization nice. And yes, I hope that sounds good to you, and it might still take a while, maybe in the spring, but I'm planning something, and it will be as lengthy as the first part of the course, I think so. So yeah, I hope it's gonna be worth it. So here, um, I have the first point, but I want to add more points to these borders. So I'm going to do a for loop, like starting at a y value that is a little bit above the car. So maybe minus 1000. And it's going to go y. It's going to go to 0. And let's increase this y value. So this is the y. These are going to be 1000 points somewhere in front of the car, where the car is going. And for the x, I am going to use the sine. So sine of, let's say, the y value. And I'm going to, let's just leave it like this so that I teach you step by step how this is going. And I'm going to add a point to the first border and to the second border using the push method. And here I have x value for this one. So this is going to be our x, the one that we are calculating for here, but offset to the left and to the right, depending on which of these borders it's going to be. So x plus this left, like this, and the y value is just going to be the y value. So I think this is good, and the same thing happens for the second one, but on the right. I think this is something that it's gonna work. But our draw method doesn't work well. So here, for each border, we are just going to draw its first point and its second point. So this is bad. If I refresh the page now, you don't see the borders anymore. I think they should come when I'm going upwards. So now I'm pressing upwards on the car, and what I see now is the top left and top right points connecting to the first one of these new points that we are adding in the borders. So road borders now has 1002, because I have here equals. So these are actually 1001 plus this first point for each different points. And I'm only displaying the first two of these 1002 points. Here we need to use kind of a for loop. So let me think I want to do it like this. I leave the move to be to the first point, and then this one here like that. So border of I now, going from drawing the lines. And I think this should work. Okay, so I refresh it, and you can see something weird happening here. Starting here. So this is that point 1000 pixels above the car. 1100 because our car starts at 100 on the Y. But anyway, so somewhere at the top, this squiggly effect happens, this small squiggly effect happens, and that is something that it's already a curved road. You're welcome. But it's, I know it's not what you're looking for. So here I'm going to scale the value of this sign by 50. And now this squiggly part of the road is horrible. So what I'm going to do is also make this sign grow slower than by 1 at each iteration. Because if the sign grows by 1 at each iteration, then in 6 iterations it's pretty much back to its starting point. So if I'm going to open here this Desmos calculator and write sine of x, so in this case sine of y, but that doesn't matter. I think Desmos needs x there. So in this case, y is increasing by 1, so we get a value here, a value here, a value here, a value here, and these in between that actually make the curve happen, they never happen. So we want to have here for the y a slower increase. So I'm going to put something like this. I hope it's going to be good. And something is there. Some curved road is there. I'm gonna move these left and right definitions from here to be closer towards the center. So the road it's gonna be less wide. Let me try to put here something like this. I think this is something good. So there is going to be a section in front where this road is curvy. And I'm kind of happy with how this looks like. Yeah. But of course, this part here, I want to still connect to bottom left, bottom right. These are things that are currently not even in use anymore. So after we add these things here, we say this borders of 0, push bottom left, and the same thing going for bottom right, but borders of 1. So this is now something, well, now this get lane function doesn't really have these lanes anymore. I'm just going to patch it somehow in an ugly way, I think. Does this work? I think I might not use that function anymore. Yeah, let's just do without it. I don't have lanes anymore, and I'm not going to consider lanes here. Hmm. But this is gonna be something different than the original code. Hmm. Okay. Now, the car sensors. So let's implement the sensors, and I'm going to do that by, let's create a new file, sensor.js, and sensor.js, like this. And inside of this, we use this class syntax. So define the sensor. And here I'm gonna do the same thing that I did in the tutorial. I'm gonna pass a constructor for the sensor to be the car. And I had comments, I think it was from Script Raccoon. I remember that username because he commented on pretty much all my videos and telling me how code could be made better. um, Not on all the videos, but on some of them. So I will comment a little bit about that soon, but let's just have this go on. He was right most of the time. So yeah, and sometimes they were just his own preferences. So I don't necessarily agree with that, but because it's just a coding preference. But here, passing the car, I agreed with him that this could have been done better because the sensor doesn't need to know where the car is. A sensor is like a box, it's like something that you put on a car, maybe you put on something else like a horse or whatever. But it shouldn't know anything about the car. And now we are basically coupling these two. So in a way that sensor must know the car's location. And you don't need to do that to write this code. So I'll show you soon. But let's tell the sensor where the car is for now. And it's going to be this ray casting. So uh, let's try a ray count of 3 and a length of 100 pixels. And then the spread, I'm gonna use, let's try 45 degrees. Mhm. And when casting the rays, I will store these rays in a rays array here, like this. So these are gonna be updated in a update method, which has to be public. We are calling it from outside. And let's reinitialize these rays with an empty array and now loop through them. So from 0 to this ray count here. I'm going to calculate the angle, and I'm going to use the same linear interpolation function for the angle. So the angle will be between minus half this ray spread plus, no, because it's let's say we are drawing it from the left to right, so we agreed this counterclockwise mode. So we say here the angle is linear interpolation between plus this ray spread divided by 2 and going to minus ray spread divided by 2. So all together they equal the ray spread angle, in this case 45 degrees, or pi divided by 4 radians. And the fractional value here is going to be I divided by this ray count minus 1, because I never becomes this ray count in this for loop. Right, so here we are setting the start location and end location according to this ray angle, and this start is just gonna be where the car is the center of the car. You could place this if you want on the tip of the car or something, but yeah. And the end, we need to calculate this a little bit. So relative to the center of the car, we are gonna subtract again using that weird rotated unit circle. So the sine of the ray angle, and then multiply this by the ray length like this. So scaling it, otherwise we don't see the length. And for the y, the same, but with the cosine of the ray angle, also scaled by the ray length. Okay, now we push each of these start and coordinates inside of these rays. And I'm using here this array syntax. Some of you were using here object syntax. I've used this array syntax and I don't really remember why. I think it's actually, it could be fine either way, but then you have to remember later in the code when you're drawing these to use the start and end attributes. So if you're changing this into an object, use those attributes instead. Now we just use the 0th and the first value there instead. I'm quite used to use arrays like this because if you do research and if you work with data, like if you do machine learning things, then these are all vectors and they are all multi-dimensional vectors starting at 0, 1, 2, and so on. And I don't have to think so much about attribute names, and somehow also the code becomes a little bit same if they are used everywhere. But from readability point of view, using objects is better. So I just have conflicting behaviors here. But okay, so let's see. Let me close this and also draw these rays. So I'm going to draw on the context, and let's go through the rays from 0 the ray count, and begin a path for each ray like this. And then I'm using yellow and a width of 2, so line width of 2 and stroke style yellow. Okay, and moving to, this is where code could be nicer. So arrays of I for each ray, and then the 0th value. So if you want to use the object notation, then this would be dot start instead of 0, and then dot x. So yeah, personal preference really. And align to, so this is to the tip of the ray from I and 1 to I and 1 of y, and we stroke. Yeah, I think this is good. And I need to close one more bracket there. Yes, and now in the car.js file, here we need to define our sensor. So each car will have its sensor is equal to new sensor like this. And the update here, okay, this code is really messy. I think what I did in the tutorial was I probably extracted this code as a move method, like something like this. I'm not sure. I don't have this noted here, but probably something like this. And then the sensor, after it's moved, then here I tell the sensor to update like this. Okay. And when drawing the car, we should also draw the sensor, right? So here, drawing the car, like this, and then I think it was drawing the sensor and the context afterwards. So hopefully this is correct. Let's try to refresh. Okay, it works, but the sensor is not rotating with the car. So I need to pass that, the angle of the car, to the sensor as well. So here, when we define this ray angle, I'm going to add here this car angle, this car angle, and that's it. Those are the differences. The only thing that we need to do is that. And this seems to work just fine. Let's try different parameters here, maybe longer rays. So that works. Let's try more rays. This is fine. Let's try all around the car. I think this is fine. Oh wait, it's not fine. I remember. It works quite well with all of these configurations, but it doesn't work with one. It should be one, but it doesn't work. And that's because if ray count is 1, then this for loop starts at 0. It's less than 1, but here 1 minus 1 is 0. So then if this is I divided by 0, this is going to be not a number, I think, or was it positive infinity? I don't remember. Anyway, it's something you don't want to have. So I need to do here this value for the t here. I want it to be half if this ray count is 1. So if the ray count is 1, then I'm gonna set it to 0.5, and otherwise I'm going to set it to what I'm doing previously. So this 0.5 is what's triggering now in case I is 1, but ray count is 1. But if ray count is 2, okay, now it's 2 because it's here like that because there are 2 lines overlapping each other, one at 0 degrees, one at pi by 2. But if this would be just pi like this, then the lines are going to be horizontal like that. And if this would be like 90 degrees, for example, then these would point forward like some antenna for TV. So it works. It's the start and end. Um, and let's put here maybe 50 or something. And this looks quite nice. Let's check the chat a little bit. The original tutorial, no, because I think I don't have the possibility to explain things as good in this live stream as in the original tutorial. So I put quite many efforts in that one. It took me 3 months to make, and it has many edits, and the code is presented by doing a lot of takes and then minimizing typos and things like that as much as I could. And then the visual explanations like animations and things like that, it's just, I can't do it live as well as there. So that's the highest quality I could produce for this course. And I think it's still relevant. Mm, okay. So skiing, interesting. Mikkel. So which vids exactly? My skiing tutorials or what? It's yeah, something that I don't. I haven't done much recently. Uh yeah, you're welcome for the courses. Uh and no, the stream is not over yet. It's 2 hours in, and I think I still need hopefully I can manage in 3 more hours. I'm not sure. I That's my energy levels for today. I think it's today is after the full day of work, so I'm already quite tired. But because I have these notes next to me, it's not that much, not that difficult. Okay. Right. So, in the sensor, all this code is doing really, it's casting the rays. So this could be extracted that it's as its own function, because ray casting is the proper term. Like this. And we need to detect if the rays are touching the road borders, right? So I'm going to go to main, and I'm going to pass to the update method here the road borders, like this. And inside of this car.js, we have here, let's call this road borders, like this. And I'm going to have to pass these to the sensor as well, like this. And now in the sensor, I need to use these here in the update method. So road borders. And when casting the rays, so this goes here as well, here as well. No. With the road borders, after casting the rays, after the rays are existing, I want to record some readings here. So the readings are going to be found using the segment intersection formula. And I'm going to type it here, this populating the readings. So let's just write a little bit top-down code. So I'm going to no, I don't want to check this here. Let me see. My code is, my notes are horrible here. Yeah, I don't need to check the ray count for this one. Okay. Yeah, okay. Yeah, I know what the problem is. So the notes that I had previously were missing a part, and I remember it when I recorded that I had to improvise that section. But yeah, so here I just want to populate these readings. So let's have this readings, reset the value, and I starting at 0, going all the way to the length of this raise array. So they're already generated here inside of this cast raise method. And yeah, I'm going to add to the readings a new reading using this private method that we need to implement. So let's pass here the ith ray like this and the road borders. And actually, before implementing this, I want to comment a little bit about those coding remarks that I've been getting. So let's check this out a little bit. So yeah, definitely here we are adding these readings here, and we could have used a for each loop instead. So that's one comment that was coming up quite often. So going with for each through these, it could make for a better syntax, more readable syntax, because we have to compare all the rays anyway to the road borders, and the order doesn't really matter here. So the for each syntax would have been better. And then here, and you can try that. I'm not going to spend time on it here, but it's one way that you can improve on the code a little bit and a good practice. And the second thing here in the car.js, so if we don't want to pass the sensor, the car to the sensor, so how do we do it? We just update here the sensor with the 3 pieces of information that are relevant. So we are inside of the car, so we could put here the X, the Y, and angle, because all of these things are important. And then inside of this sensor.js in the update, then we could have here something like XY angle, and these should be passed to this cast rays as well. So in this case, this car is no longer needed there, and this XY angle going here is actually going to replace these car references. So here, this car angle just becomes angle, the third parameter. And then XY, you can actually write this in a simpler way like this. And this is just x now, the x and y parameters here. I could even move these up a bit because now they fit nicer on the lines. So this way we have an error. Oh, my get reading function. I chose a bad time to stop this. So let's disable it a little bit. And continue that get reading function in a second. I couldn't find a great time to discuss about these code comments. So this script raccoon was really making valid points. So you see the code is still working, but now the sensor has no idea what the car is. It's just being told inside of the update method here where to be. It's like the car is telling the sensor move with me, but it doesn't know that it's on the car. So it's a little bit cleaner code like this. You don't want to pass objects and then refer to them in both directions. So yeah. Okay. Okay, many thanks in the chat. Great, thank you for watching. And it should be accessible also at the end. Yeah. So we will keep the stream later as a video, I'm quite sure. Right, so we were doing here something about the readings. So this get reading method, I hope this will work. So using the given ray and the road borders, so we have to pass both of those here. We are going to calculate all the touches, like all the time the ray is touching a road border, like anytime it intersects one of the borders. So I'm going to store these in an array. There could be multiple of them. And then at the end, when we have all the intersections, we're going to keep the one closest to the car, because if the ray touches many things along its way, then the first one is what really matters. That's the first obstacle, and the others are secondary. So let me implement this by going through the road borders. And this is one other place where I could have used the for each. Maybe I do it soon, but let me just follow the notes for now. So maybe just not talking that I could do it, but doing it is better. So let's say the intersection between the first point in the ray, the second point in the ray, so the start and end if you want to use the object notation, and then the road borders of I of 0 and the road borders of I of 1. And this code will need to be changed now, because we don't have just 2 points defining the border, the start and the end. This is going to need to use a for loop and go through all the points in the ith border. So bear with me a little bit. I just want to make sure that this code is the same as in the tutorial first, and then modify it. So then after we do this, of course we need to implement that. So if we have some touches, if we don't have some touches, so if the length stays 0, then I'm just going to return null here for the reading. Otherwise, I'm going to calculate these offsets. So how far are these these points from the starting point of the array. So this get intersection function is actually going to return not the point only, but also the offset from the starting location, like a percent value. Those are important when working with the neural networks later because it gives us normalized values between 0 and 1 to have as the inputs. So the offsets here is gotten with this map method. So I'm just taking the offset value from each of these intersection points there. And let's take the one with the minimum value. So the minimum of this offsets array, but I'm using the spread operator here because I need to call the min function, and the min function doesn't support the array as a parameter. So I'm spreading that into many parameters. And finally, we get the one with the minimum offset. So we just return here from the touches, we find the one where the offset is equal to this minimum offset that we calculated. Right. And let's save this and move into utils. And I'm just going to implement this get intersection method by copying the code. So I have separate video where I explain it step by step and why it works. And I think that you can check it out if interested later. But the end result is, I need to be really careful here because it has these variable names like here we have get intersection between point A, B. So this is one segment, and C, D, another segment. And each of these are points, so I need to make sure I have them in the correct order here. The top, it's the top part of the fraction. So dx minus cx, ay minus cy minus dy minus cy times ax minus cx, and then the u part, the top part, because the bottom is going to be the same. So cy minus ay times ax minus bx. I really hope I don't make some mistake here. Yeah. Okay. And then the bottom part, dy minus cy times bx minus ax, dx minus cx, by minus ay. And then we need to check if this bottom is 0, because if it is, then we cannot divide by 0. So, right, and now we can get the t fraction like this, and the u value like this. And this next check is just because we want to do the intersection of segments, not of the lines that they are on. So I'm going to do here if t is between 0 and 1 and u is between 0 and 1, then I know that those segments are actually intersecting, not the continuation of them. So this is important because some of the rays are definitely going to touch something if you extend them to infinity. And now the road borders are even going to be made of many small segments, each of those extended to infinity. It's pretty much a guarantee that all the time everything is touching everything. So we need this, definitely. So I'm going to return here the points. I get this location using lerp. So between a of x, b of x, and t, and then between a of y and b of y of t. Yeah, we can use just one of them. We don't need to use u at all, only to see if it's inside of the second segment here. So this check is needed. And then the offset, the t offset, because the ray is given as the first parameter, and we want to know how far along the ray it is. This last return here is in the case that this bottom is 0. So if the lines are parallel, pretty much, and they never intersect. Okay. Now let's go back to the sensor. And when I'm drawing these, I want to make it clear what is happening. So let's figure out where this end of the ray is going to be. So now we move to the start point of the ray here, and then line to the end point of the ray. But if it touches something, I want to draw to that point instead. So here, a little bit of logic, get that end point, and I will do it like setting it to the value where the ray ends, so this one from here. But if there is a reading, yeah, I think it's here, then we update this end to readings of I instead. So that readings of I, because of the way we implemented now this get intersection, does have an x and y, like a normal point, also the offset, but we are not using it here. So now this end is something that we are going to use here. Like so. And if we want to see the continuation part of the ray, like where it's not seeing, then I think we can just copy this from the end. So from the end to the new end, the one that might be closer depending on the readings. Okay, so very many things, and it's not going to work immediately because we have this problem here. These road borders, only the first two borders are considered, so it's not gonna work. I think if I'm gonna drive all the way up to where the first road borders are, it still doesn't work. Okay, something is wrong. Too many things here. So let's just remove this new code. I'm not certain about it. This stroke is something I misplaced. It should have been twice there. Okay, let's see what happens if I drive all the way up and if the first two road borders are... Yes. So, sorry if this is confusing, but you can see here it works just fine. But now if I go down, it stops working. And it stops working because I'm only checking the first point here. This one. Basically, the segment coming from the first point in the road border of I and the second point. So this is the second point and the first point is at infinity. So this segment here is considered in our code. Also this one, because we are looping through the road borders. So we need to fix this. We need another for loop. And let's try to do this as a for each. So script raccoon, this is for you. So border goes into this. And let me remember to close this parenthesis. So now I can just call this border of 0 and 1. A little bit simplified than earlier. So this is not changing anything yet. It's still going to work the same as before. Only the first segment is considered. But if you look at the syntax, it's neater. And this border here, it's not anymore like it was previously borders of I, of 0, of 1. It's kind of like here in the array. So I do definitely think that this is an improvement in several parts of the code. And here, let's fix it so it goes through all the borders. So I'm going to do a for loop. Let's start it at I is equal to 1 and less than border length, I++. And these things will go inside of the for loop. Now, this will be border of I minus 1, and this will be border of I. So every 2 consecutive points in the borders forming the border with the complex shape now are taken into consideration. I think this should work. I think so. Let's refresh. Okay, so this looks nice. I like it. So now the rays are definitely contained within this thing. Of course, I still haven't implemented the damage of the car. So that's something I still need to do because now I can go off the road. And that's not what we are going to do. We are going to damage the car when it does that because it did a bad thing and it needs to be punished. I need a break. I'm gonna look at the chat a little bit. Ah. No, not many updates, and I suspect some of you are getting tired, and I am getting tired. But I will pull through with this thing. The final program, I can put it on GitHub, probably. Yeah, let's see. I'm not sure about the quality of some of these things that I'm improvising now. But as I mentioned previously, I will make a whole course about making the roads special and making a road network and making the car work on roads from probably OpenStreetMap. So we will have a future version of the course where the cars are going to be driving on real road networks and make the simulation better. And then we might have to do some more advanced AI to cope with that situation because this is kind of an easy scenario. and it's enough for the basics, but I want to have something a bit more special. Yeah, sure. I'm going to put the code somewhere. It's gonna be very similar to the other one, but let's see. I think I will add a new folder in that version on GitHub. Maybe call it live or something, and update it. But I probably will update you in the community tab in the posts there. Okay. Hmm. So the next part is gonna be this collision detection. So collision detection, yeah, there was the problem that here we're drawing the car rotated by using this kind of trick. But if we do collision detection, we need to know where each of the corners of the car is. And for that, we have to use trigonometry again and polar coordinates, I think, and define a polygon mm, for this car instead. So let's try to do that. Yeah, I'm not gonna insist too much on this code. I'm just going to copy it. It was explained in the tutorial with a little bit more visual emphasis there. I will explain it as I type, but original explanation is probably much better. So, mm, I need to calculate that polygon. So based on the x, y, and the angle that the car is rotated, I need to know where each of the corner points are. Let's see. Create polygon. This is the private method that is going to do this. And these 4 points are going to be in this array. I'm using again an array because if I call these top left, top right, bottom right, then I'm stuck to using a car that is rectangular in shape. And really, you can expand this to look differently. So yeah, I prefer this array because then it can have any number of points. So the radius here is going to be half the diagonal of the car. So if the car has this diagonal of something, actually the diagonal length is the hypotenuse between the width and the height. So the radius that I want is half of this. So from the center, I want to use the radius and then rotate at different angles relative to that car angle there. So I'm going to divide this by 2. This is the radius relative to the center point of the car. And the angle that we will use, this alpha, is we can get it from the arctangent of the height and the width. Yeah, I think that this should work according to my notes. And then we add to these points a new point where we do the conversion from this polar coordinate, so angle and magnitude, the radius is the magnitude, back to the x and y. So I'm adding here to the x value of the car Again, that's kind of annoying rotated unit circle from here. So minus the sine in this case, and then angle minus alpha, because we want to take into consideration this angle between the width and the height. So from the center, we get this. It doesn't matter if we put here width and height divided by 2 because the arctangent is the same. So no matter if the triangle is similar, like half of the triangle, then the result is the same. So here, that's why the half is missing. It's a little bit mental math happening and not obvious, but I will make a course on trigonometry and one on linear algebra in the next months. So please wait for that. The same thing here. So the same value but with the cosine, and we scale it by the radius. So this is just coordinate conversion from the polar coordinates to Cartesian coordinates. Right, and this value is going to be same for others. So this is just one point of the car bounds, and here I'm going to have the angle adding this alpha. So top right corner point, top left corner point, and then bottom bottom left corner point. We have to add 90 degrees to this, or pi, sorry, 180 because it's opposite degrees. So math pi. Let's just leave it like this. So our car will be a triangle for a while and then fix it. So just to demonstrate how it works. So now this create polygon, I'm going to have to regenerate it every time after the car moves. So here. And let's store this polygon as a car attribute. So this polygon, or do I really want to do this like so? Yeah, I think it's fine. So this dot polygon is equal to calling this private method. Okay, and let's update the displaying as well. So here where we're displaying this in this way, I'm not gonna draw the rectangle anymore. I'm just going to draw using the new polygon. So let's say begin path, and then I'm gonna move to the first point in the polygon, x, and the first point of the polygon of y. And now the remaining points, so I at 1, and then going to the length of the polygon, we will line to the ith point in the polygon x and y. And fill. This is going to be the default black color. So let's try. Of course. Oh. Oh, I'm not returning. And let me make these sensor arrays less. So there are too many of them. Let's say, uh, is 5 enough? Maybe something like that. So you see the car looks like a triangle because it has just, yeah, actually both top points, but then bottom right point, actually. It's there. So if we want to make it as a rectangle, then here we subtract alpha as well. So one more point like that. Okay, different order here. Done. So now the polygon is like that. And hmm, we can move on to check the damage, but my live stream somehow collapsed there. I have to re-sign into the computer, so it takes a while to check it. I'm sure that the streaming still works, but I can't see if it's working, so it bothers me. So somebody's asking if these can replace the original videos. This didn't happen in the original course. Okay, let's take a quick look at the chat. The machine learning project. It's going. It's going. I have between 400 and 500 submissions. So if there were 8 drawings for each, that's like a lot, like 4,000 almost drawings, and it's definitely enough to do the course. And I am starting to process them tomorrow. So I haven't done anything yet. I just checked that they are collecting and that the data is coming. Um, I think that the course will start in January. So that's my aim. Sometime in January, it should be the first lecture. And I might record a first part of the course in the beginning and then maybe have some interactive sessions with you guys and then record the second part of the course based on things we do together. Let's see. I'm still thinking how to make the course interesting. But yeah, I'm not forgetting about it. So definitely coming. And yeah, this is live, not pre-recorded, but because I have these scripts next to me, I'm cheating. I mean, I don't code so well in normal life, so some of this is improvised, but most of it is just copying code or um, making small modifications to that code. Yeah. Okay. Great. So let's do the damage assessment. Here in the constructor of the car, we also want to record if the car is damaged or not. So we begin with it false. And in the update method, after we get our polygon, which we will use for the assessment, we will update here this damaged is equal to assess damage on the road borders. So we need to implement this function next. Let's make it here. So assess damage road borders, and we are going to create a function for polygon intersection, so helper function, and we will use it here. So a little bit top-down implementation now. I pretend that function exists. So going through all the borders like this, if the polys intersect between the polygon of this car, the one that we just generated with the create polygon private method, and the road borders that are being passed as a parameter, the ith road border. This code could be rewritten again using for each a little bit better. So let's return true and false if we didn't return true. So no damage if none of the borders are affected here. Let's implement this polys intersect in utils. So somewhere here. So the parameters are just two polygons. In this case, the shape of the car and the side of the road. The borders are not a polygon, they are actually polylines in this case. But yeah, it's a poly something. In the original tutorial, it's not even a polyline, it's a line, but I still used this notation. So yeah. Let's go through all the points of the first polygon and all the points of the second, and we're gonna do a segment intersection between each of these. Not the intersection between 2 points, but each of these 2 points and the following ones in this polygon sequence of points. So the touch is going to be get intersection between poly 1 of I and then poly 1 of I plus 1. But we want to wrap around so that the last element in this polygon, actually this would give an error if we don't do anything to it, because it's essentially going to try poly 1 of poly 1.length at some point, and that value doesn't exist. It ends at poly 1 of length minus 1. So what I'm doing here is wrapping around using the modulo operator. So when I is poly 1.length, I plus 1 is poly 1.length, then doing this modulo operator here brings it back to 0. This might have some negative consequences with our new complex roads. But let's see. Same for the J. Okay, if there is a touch, so if it's not null, then I return true. And then here I return false. So this helper function just, I mean, I do it because I don't want to write all this messy code back in the car here where we are doing where we are assessing the damage. Now to see if this works, I'm going to go to the draw method here and color the car differently. So if the car is damaged, let's make gray fill style. Otherwise, we set the fill style to black. Okay, so if I refresh now and I'm not stopping the car yet, but it doesn't work. And I know why. Um, this wrapping around here, eventually it's gonna try to consider the road border a polygon. I mean, not a polyline. I think that at some point it reaches the last element and then it compares the segment that is the bottom point, like bottom left, connected to top left. So even if this line goes now like this and then the curve and then at the end down, it will still check the intersection between this last point and the top one. So an invisible line is there in our damage assessment here because of the way we implemented this. Let me try to go here less than 1. Then this part doesn't do anything. Okay, so it's a bit hacky. I think that what we did is we eliminated that problem of the invisible vertical line, but we also have another problem that the segments of this polygon that are taken into consideration of the car are something like maybe this segment here, and this segment here, and we're no longer wrapping to the beginning. So collisions between this segment and the borders are never calculated. But because when you intersect something like this, you can't really intersect just this segment. You have to go in and out of the polygon. So there is no bug in this kind of unintuitive implementation here. There's no bug. Everything works as I expect it to work. Like it's getting damaged only when it touches this curved road now. So it is perfect. But the code is not well explained anymore, and I'm not very happy with that. But for this demo session, I'm gonna leave it like this. So the way I would fix this, if I would have more time and energy, is I would leave these parameters as polylines, and I would make the poly of the car actually repeat the first point again at the end. So it would be a 5-point array, even though it has just 4 things. And then the road would not have that there. So then we don't need to do the loop, and we also don't forget to detect one segment intersection of the car. But again, because of this aspect that when some segment of the car touches, another one must touch as well, unless the road would end. Wow. Yeah, this is interesting, but let me see. Can I? Yeah, I can demonstrate to you maybe better what I mean. So if I don't put the last point in the road border like this, then I think that I'm going to have I'm probably going to be able to demonstrate something here, that one of these sides doesn't work. This one. So it wasn't the bottom side, it's this side. Um, all the other ones work, but that one side that is the one that doesn't work, it's there. But again, because because that side is because our road is essentially infinite. I mean, I'm not going to play this until we get to the end of the road, and that kind of thing might happen. Um, it's fine. It's fine for this. So yeah, I mean, the road never ends, so this problem can never happen, even if um, the car is like that. You see, sure, the detection doesn't work for this segment, but at some point the road must pass out of it, so it will happen for that segment. It's quite hacky. Um, let's fix it. So yeah, so here these are going to be polylines. And when we do this polys intersect in the car damage assessment here, the polygon here is not just going to be the polygon. It's going to be the polygon where the first point is repeated at the end. So I'm going to write this maybe using the spread operator followed by this polygon of 0. So I'm essentially spreading this one into its elements followed by the first element again. And this works. But now we fixed the other problem, that thing that annoyed me so much that I had to use mental power. So I'm sure it fixed it. I hope. So no more problem here or here or here or here. So now I'm happy with this. Okay, it wasn't hard at all. This spread syntax is actually quite useful in these cases. Let me quickly check the chat for more things. Mm-hmm. How old I am? I don't know. Uh, born in 89, so 34. It's funny, but I always have to somehow calculate this. So I'm 34. Um, I think coding is pretty much practice and also getting used to the code in the company where you're working and the code that others are doing, and I recommend coding with others so that you get their way of doing things. And if I would work in some company, like when I went to Microsoft, I really had to get used to the way people were coding there, and it was a little bit different. And it project was quite large and a lot of code, something I wasn't that great at working. This software engineering is not my um, best ability, like the architecture of the software. I'm like to think that I'm very good with algorithms and problem solving in general, but about structuring large pieces of code, I have many things to learn as well. And I think some of my students are better than me because they have went into companies and they are experiencing these large code bases more often than me. So you can always learn new things, and um, the things I know are maybe more useful in research or in companies that do more advanced things. But um, yeah, I wouldn't be discouraged because it's really after you get used to what the project is doing in that place, then making updates and patches, it's not that demanding. And that's what you do most of the time. You don't implement large software components. You do small things on logic that you understand really well. Uh, of course, algorithm complexity is very important. I consider it all the time. Maybe I should talk more about that, but so yeah, it's I consider it often, of course. And some implementations in JavaScript, I also try to uh, keep an eye on. Like for example, that if you work with arrays and you do a push at the end of the array, I know that that's a constant time operation and I use it a lot. Sometimes I use the ones at the beginning of the array, but I know that those shift the whole array and they do linear time complexity. I try to avoid those, but really I do things like that only if it starts affecting. So mm, if you only do that shift operation at the beginning of the array once, and like in this case, maybe, okay, once per frame, if the array is very small, it doesn't really matter. So I will use that rather than implementing my own two-ended linked list uh, in JavaScript. So I don't just re-implement everything from scratch if I need some better data structure just to get a better time complexity in a case where your things are small. So who cares if you do linear time complexity if n is equal to 10 or something? It's like nothing. So you might as well use that. Uh, of course, if you really care about optimizing absolutely everything, mm, you need to put a lot of effort, but almost nobody does that. So, yeah. Okay, lerp function for calculating the age. Well, lerp could be used to interpolate between two different ages. So, if you want to know what is halfway between my age and your age, you could use lerp for that, I guess, or I don't know, 30% of the way. Mm, maybe. And lerp, um, like here, I'm using it quite little in this. I could implement point version of the lerp, so instead of writing here that, I could also use lerp in 2D. If you want to practice more with linear interpolation, you could try extracting a function like that. Um, I think it's overkill because this is so far the only place where I'm doing that, so I just called it twice. These are decisions you have to do, very subjective things. Some people say this is good, some people say this is bad. Let's make another function that works with two of them. Yeah. Okay. So let's add back these points. They are here already, but let's refresh. And let's make the damage of the car actually affect. So if we go back to the car update method here, if we are damaged, if we are not damaged, then we do these things. Otherwise, well, sensor can work even if the car is damaged, but the movement is cut off. So now I can't move anymore. Mm-hmm. So I started studying computer science in high school. So 2004, I think. I didn't know it well back then, and I studied C++ programming languages. And then I wasn't so attracted by it. But then I learned about this Flash software from Adobe. Back then it was Macromedia. And the programming language was ActionScript, ActionScript 2. It then changed to ActionScript 3, which is very similar to JavaScript. So Flash was this animation software that also supported scripting and making games. This became completely deprecated now in 2000. I think it was in 2000 browsers stopped supporting Flash. But at that time, YouTube was made using Flash. A lot of things were made using Flash. Now I think it's called Animate. So Adobe still has it, but it's called Animate. You can still code using it, but people mostly just make animations with it. So that's what got me attracted to coding, because I was doing the same things as now, but in a different language, a different environment, and I could also draw these things with my mouse. Um, some of these things, and I wasn't so good with mathematics back then. So yeah, that's what got me into coding. And then I studied ever since. Like after high school, I went to do my bachelor's in computer science in Romania. I'm from Romania originally. And then the master's, I did it in Finland. I moved to Finland. And I've been here for the past 11 years. So I did my master's, then I did my PhD. A lot of coding in these times and researching algorithms and so on. Um, yeah, and I always learn new things, but I don't really, mm, I don't really learn them by reading tutorials, watching tutorials, or reading documentation. I learn them by just practicing and experimenting with things, and then I learn something new about, I don't know, the universe by doing some kind of experiments. Uh, I just do it for fun. Of course, teaching at university is a little bit different because we need to focus on what students need when they apply to some job. So we want to teach things that companies need uh, the students to be familiar with. Usually, I teach things like Node.js, React, React Native. So these technologies that you use nowadays for making different mm, different websites, different mobile apps, hybrid mobile application development, and also um, I teach some Python. Mm, these things that I publish on YouTube are mostly me having fun, and it doesn't mean that they are not. good for you to practice, because if you're having fun when you're doing something, you're most likely enjoying that, you're learning that, and you want to learn more doing the fun stuff. And sure, maybe making this self-driving car simulation is not something that you will be asked to do in almost any companies you work on. But knowing how to use JavaScript, or knowing some things about algorithms, about time complexities, things that I talk about in my videos, these are useful for pretty much every job. So practicing while doing something you enjoy is the reason I do these. I just hope that some of you will mm, like the same things that I like, and that you get motivation to practice coding, doing something fun. And yeah. Okay. Mhm. So I actually don't do research much anymore. I've stopped doing research about 2 years ago. Some papers might be still coming out because former colleagues are still uh, battling reviewers. Like papers I've submitted some time ago, they take a long time to be reviewed, and then updates and so on. But I've stopped doing research. It was somehow too demanding, and I'm now just teaching. So I it's much less stressful, because research is always like this. Um, Reviewers are quite harsh typically, and you need to deal with them, somehow accepting their suggestions all the time, unless they are really irrelevant. But then you have to battle with them, and of course there are deadlines. You have to make project proposals, and it's a lot of work to do research and to do it successfully, and you have to publish a lot and guide students and supervise them like PhD students, and then somehow you're responsible for their careers in a way, because you're working on papers together and they are inputting many years of their lives into it, and it's a lot of responsibility, and I couldn't continue doing that. It's especially when my son was born, I thought that it's too much to carry on in my head. After I go home from work, if something didn't go well, I was still consumed by those ideas, and what didn't go well. And mm, I decided to change a little bit the career back then. So, yeah. Okay. Yeah, well, of course, theoretical computer science has important applications, and knowing about time complexities and things like that, it's good. But if the curriculum tends to be so theory oriented, it also tends to be interesting to a very small group of people, and others find it not useful. Many people complain about university systems that you study for many years and then you don't know why you learn these things. And I disagree. I mean, I find uses for these things in my fun projects, things I do on YouTube. But the truth is that many of the programming jobs are not rocket science, and most of them are not rocket science. It's much more software engineering and organizing the code than figuring out code that does algorithms that do something really impressive. So uh, much of the difficult things that you learn in university might seem like not useful, but that's just because many jobs are like that. So, hmm. Okay, too much talking. too little coding. So damage is done. Now we have this curved road here, and it's kind of an obstacle by itself. Like, it's not actually very easy to navigate around this. I didn't make on purpose this accident. It just happened. So it's not that easy to navigate, and it's kind of already challenging. But I will implement some of the traffic to some extent. It might be silly because I'm not gonna make the dummy cars follow the road. I could, but it takes too much effort and I'm getting tired already. So that will stay for the second part of this course. I have in mind some crazy things for that one. But next year. So now traffic. I'm gonna go to main.js and let's implement here some traffic. And a new car. Now, what do I want to use here as this x coordinate? I think I'm just going to use 100. So I just put it above, I mean the same x, but somewhere above our current car. So let me put here 100, and the y-axis is going to be somewhere negative, up in front. It's just going to be one obstacle there. Yeah, let's just leave it like this and see what we get. So you can extend this traffic somehow if you want later with the code. You can try to make it follow the new curved path, but I'm not gonna bother. I'm just gonna have it go through the road, like it's some kind of tank that doesn't care about where the road ends. Yeah, it's funny to think about it like that. But yeah, so now that we have this one car in the traffic, after I update this before I update the car, I want to update the traffic. So let's do a for loop, go through all things in the traffic, and then each of the item in the traffic goes like that. Let's just not pass anything here. So I'm gonna put an empty array there. So I don't want the traffic to be affected by the road borders. And here, after I'm drawing the road, I'm going to draw the traffic as well. So let's have a for loop. Like this. Okay. Does this work? Okay. Oh yeah. So now I'm controlling this car from traffic instead, because these key listeners are being overwritten. So this other car has this car in the traffic has also has the key listeners, has the controls as well. So I'm gonna have to make a distinction here and say this car is gonna be controlled by the keys, and this car here is gonna be our dummy tank. Yeah. So we need to pass this other parameter here. It's gonna be the control type, and we are gonna add this control type to the controls as well, like this. So now I'm gonna go back to the controls here. Let's just pass here type as a parameter, and only add these key listeners if this is a keys control type. So let's say a switch for the type, and if this is the keys case, then I'm going to move this like that and continue with break. And then the case for the dummy car, I just want the forward to be set to true. So this dummy car is going to move by itself like this. So let's refresh. And you can see there that dummy car moving, and I can't follow it because I can't even catch it, because every time I turn, my vertical speed decreases. So so these, you can see it actually going further and further when I'm making these turns. So if I want to catch it, I'm gonna have to set the dummy's max speed to something else. So maybe here we have max speed equal to 3 by default, and where we define this dummy car, I'm just gonna put it to 2. So in this case, it's going slower than me, and I can eventually reach it. And it's the tank, it's going through all the road borders, but I don't mind. What I do mind is that I'm not getting damaged by it. So that's something that I still want to do now. And let's try this. Also, one thing that I don't want is the dummy to have those sensors there in front. They don't work anyway because it doesn't know about the road borders. So let's go to the car here, and if this control type is not the dummy, then we will have some sensors. And now this update here, so if there is a sensor, because it could be that now it doesn't exist anymore, then we are going to update that sensor. And the same thing goes for the draw here at the bottom. So something like that. And in this case, now that dummy car at the top doesn't have the sensor. So just a little bit saving resources for something that we don't need. But now this detecting the damage with this car as well. So here where I'm going to do the car.update with the road borders, I'm also going to pass here the traffic as well. So it's gonna take that into consideration. And because this update is here as well, I'm just going to put, I don't want to damage those traffic cars. They are really gonna be like tanks. So it's not gonna be damaged by us or any other traffic elements if we add more, but let's see. So now this traffic is passed here to the car update, like this, like so. And I need to pass this to assess damage, for example, and to the sensor update function, because I want the sensors to see it as well. Okay, so let's try to do the sensor first. And I'm gonna go in sensor.js and update not just the road borders here, but also that. And I'm passing the traffic to get reading as well. And then here in the get reading with this traffic third parameter there, I'm going to have to do this same kind of thing as here. So let's see. Going through the traffic one by one, I'm going to get a reference of the polygon, traffic of I dot polygon, and let's go through each of the elements in this polygon, each of the points. And calculate the intersection like so. So I'm calculating now the intersection with each individual line segment of the polygon, because the ray may intersect a car twice, like first when it enters the car and then when it exits. But again, it will be something that we add to these touches, which only the first one is kept afterwards. So ray of 0, ray of 1, similarly as here. But now we get this polygon of j and j plus 1 modulo this. So our trick to wrap around the polygon should work here, because these are polygons, not polylines, and I believe this is just fine now. So if we get the value here, I'm putting it inside of these touches, and that's it. So now, and yeah, here I could write this using a for each. It's probably gonna be not much different, because this traffic of I'm already getting only the polygon from there. So this syntax is fine, I think. But if you want to practice for each loops, this is where you can recode this using for each. It's arguably a little bit nicer, since the order of processing the traffic just doesn't matter. So it's fine to do it like that. Okay. Does this work? So if I touch now this other car in traffic, do I get damaged? No. So it doesn't work. Why doesn't it work? Wait, no, I shouldn't be damaged. I should only the sensor needs to be affected by it, and that works. You can see the arrays of my car's sensors being affected by it. It works. The damage, we didn't implement it yet, so that's easy, I think. Let's have a look. I don't have notes on this, but how hard can it be? So here, assess damage, and I'm using the traffic. Yeah, traffic. So we have poly intersection here for the road borders. And for the traffic, the same thing with the polygon here as well. So traffic of I dot polygon, and this poly, I'm actually gonna do this wraparound trick here as well with this new poly variable. So this should work, I think. And now if I touch the other car in traffic, it's gonna damage me. All right, so let's look a little bit more at the chat and move on to neural networks. Salutare, Alexandru. Okay, so many things here. Yeah, about not being prepared for the business world. So it's common. I think everybody is not prepared when they go somewhere new because you just don't know how that company operates. And there is usually a training period where you're learning all these new ways of doing things. Um, yeah, I mean, um, anybody has to adapt to that. You don't go there and impose your way of doing things to everybody. You should be flexible and accept that that's how they do things there, even if you don't totally agree with that. It's better to make the code um, in a way that it's how to say, in line with the existing code there. So sometimes you can say that this shouldn't be done like that if you really think so, but it's more important to have consistent code than people's different opinions all the time. My stream computer decided to shut down again. Okay, but I will check the chat a little bit later again after this computer restarts. And I type the password. I don't know what web workers is. I think it could be, okay, multi-threaded. I've heard the word, but I don't have experience with that. I think one of my students used it once for some reason. It might have been some swarm intelligence algorithm, just some kind of assignment for algorithms course or something. And he might have used threads in JavaScript for that, but I don't remember details. Yeah, sorry, I just don't know about web workers. No plans for TypeScript refactoring, and okay, so the plan for the second part of this course, probably coming in spring, will be that I want to make the roads like a real road network, something that you could use part of OpenStreetMap or any kind of map system that has road topology in our self-driving car simulation. So then on that, doing that second part of the course, I want to update the existing code base to support this kind of functionality. And at the end of that, so first I'm just going to patch the existing code base with that. And at the end of that, I'm going to do most likely a lecture where I refactor the whole code. And then if somebody knowing TypeScript, I don't, or if I learn TypeScript by then, I will consider that. But if some of you knows TypeScript and want to refactor the code base, I recommend being patient and waiting until then, because I will apply some of the things I'm doing today, some of the updates I'm doing today, I will include also in that refactoring session, like things to do with like this for each loop stuff, or what we did now where we decoupled the car from the sensor, things like that. So yeah. Okay, somebody, the new alternative has an explanation for these workers. Thanks for that. And yeah, all those who say thank you and so on, I'm happy to do this thing. So let's go on. The road network, the neural network. I don't know if I wanna explain what the neural network is. I think I'm actually gonna play part of this video. I prepared it here already. So it's the funny part that I had the most fun with when when making the lesson. So let me just play this section of the tutorial that explains what the neural network is, and then I start writing the code after that. So let me laugh at myself talking here for a few minutes. Neural networks are computing systems inspired by the biological neural networks in our brain. These are some neurons. These branch-like structures receive the signals. When stimulated enough, a neuron will fire a signal through its axon. So a single neuron does something really simple, and intelligence only comes when they work as a team. You see, your brain has 86 billion neurons. You also have quite many of them in your spinal cord and sensory organs, like in your eyes and ears. These sensors send signal to some neurons that pass it to the brain. There, the processing happens like a chain reaction where some neurons fire, some don't, eventually signals arriving to motor neurons that pass them through your spinal cord and make some muscles contract in very specific ways. Hey! A lot happened in just a split second. Let me try to slow this down and explain it to you. Pay attention. Sensors inside the ear pick up compression waves from the air and send signals to the brain, which figures out the direction based on different intensities. Signals then travel to neck muscles, tell them to contract and turn the head in that direction. The eye catches a glimpse of what's happening, and new signals travel to the brain. Peripheral vision is blurry, but good enough information exists to detect some kind of object approaching, and new signals travel to facial muscles to contract and protect the eyes from getting hurt. Eyes are really important. At the same time, the brain begins a kind of defense protocol by sending signals throughout the body. Time passes and the image becomes more clear. The brain does pattern matching and recognizes the object as a ball. Contextual and historical information will play an important role in what happens next. Let's stick to the first one. The brain concludes there is no threat and uses knowledge about physics it learned during its lifetime to predict where the object is headed. It then sends new signals to the muscles to contract in slightly different ways to catch the object instead of blocking it. And the rest is history. One history where the brain did a good thing and not much happens afterwards. But sometimes this happens, and the brain learns it did something wrong and configures itself so the same thing doesn't happen again. Hopefully. Anyway, I'm feeling really good about myself now that I know my brain can do something like that in an instant. Hope you do too. Our car's neural network will do something like that. Neurons on the first layer will be connected to the sensors. They will send signals forward a few times. And the last layer will be connected to the car controls to make it actually do something. Spoiler alert, we'll be working with relatively small networks here. But that's okay, because we actually don't need very large networks to solve this problem. Now, implementing all this in one shot is, well, okay. I had so much fun making that section of the video. Uh, yeah, some more comments there. Yeah, thanks. I'm happy you like things. I do. Singing the song, I guess you mean the intro song. I I don't sing it now. And I do have a Discord. It's there. It's linked in the channel banner, but I'm not there all the time. So I will probably take better care of that Discord server at some point. And then TypeScript. Yeah, it's great with bigger projects. I know what it is. I know why it's useful. I just never studied it, and the bigger the project, the more likely it helps you. But I do know that there are some tricky things about the types there, and it can cause errors that are hard to debug. Okay, so neural networks. Let's make a file, network.js, and I'm gonna go a little bit faster. I'm just gonna copy the code I see here in my notes, and yeah, WebSockets for multiplayer game. I want to do it. I want to make many things with the car from this code, like maybe having some kind of simple racing game, multiplayer WebSockets. I can do that, but I just don't know when. I have so many other things on my list. I have a very sad list of almost 4,000 ideas. I know that might sound crazy, but if I look at that list of ideas, I know that some things are not so exciting anymore as when I originally got them. And if I would consider doing all of them, even with one video per week, I wouldn't live long enough to do all of them. So I need to prioritize something. But I do want to do WebSockets someday. Well, let's see. So let's go to network.js and start implementing this. So I will go a bit faster, implementing the one level of the network. So the constructor here, the input and the output neuron counts. So these will be used to define the arrays. So the inputs, a new array with the same size as the input count. Outputs, a new array, same size as the output count. And the biases also go here. New array of the output count. So the biases are with respect to the outputs. And some people mentioned here that I could have just used one more node for the input and then considered the weights for this one extra input node, and that input node would be a 1 all the time. So that's just another way of implementing this. I stuck closer to the biological representation where the neuron has a threshold above which it fires. Yeah. So let's do the weights next. This is gonna be a matrix, so I avoided a little bit matrix notation here by just working with loops and arrays. So each of these rows or columns, depending on how you want to look at it, is a new array with the output count. Yeah. So let's write our randomization here. We just put random values in this network, and we are going to randomize here the elements inside of this level. I'm passing this because this is going to be a static function, because at some point I serialize this and I want the static function to stay. JSON serialization only considers these attributes here, and I need to have still the randomized function somewhere. So best thing I could think of is keep it as a static method part of this class. If you don't need that kind of local storage, if you don't want to persist when restarting the page, that's fine. You can make the restart button, not refresh the page, but just reinitialize everything. But I wanted to keep track of the best car, even if I try again next week or so on. So it's what I decided for this tutorial. So let's go through all of the inputs. And all of the outputs. And now I'm going to set the weight at this I and j index to a random value between 0 and 1. So math random is between 0 and 1, between -1 and 1. So math random is between 0 and 1. Math random times 2 is between 0 and 2. So if we subtract 1, it's between -1 and 1. So these weights are essentially having something like the negative ones are like inhibiting the signal. All right, and I need random values for the biases as well. Times 2 minus 1. Okay. And let's implement the feed forward method. So I'm going through all the inputs and I'm setting them to these given inputs. So this is whatever comes from the sensors. I think that here somebody mentioned in the comments, I don't remember who it was, that I could have just written something like that. So I'm creating a new array with the values from the given inputs being spread like that. I think this should work, but now we know if it will really work because I tried. So it's much neater code. And let's calculate the sum. So the sum coming from all the inputs processed by the weights, the weight values. And here I'm going to check if the value is greater than the threshold, this bias. And then the output is going to be a 1. And otherwise, it's going to be a 0. And we return these outputs. Yeah, okay. So this is just one level. I call the level a combination of input-output with the weights and biases, but neural networks tend to have more hidden layers, so that means at least 2 levels. We don't need really this. This is one observation that somebody made, that I had used one hidden layer, but they tried without a hidden layer and they still managed to solve the problem. Our scenarios here are not that complex, and you could solve them with a simpler network. Let's experiment with that as well, but I still want to implement here the general neural network class like this. And this takes the parameter of an array of neuron counts. And it's going to create multiple levels using the code that we have just written here. So going through all of these values, like so, I'm going to push into this levels array a new level with the input-output values. So I'm going to take neuron counts of I and I plus 1, the next one in this array of neuron counts. And that's it. And this neural network class also needs a feed-forward method that just calls this other feed-forward method multiple times. So with the given inputs and the whole network this time, I'm going to create a first version of the outputs after the first level feed forward is called on the given inputs, and then levels of 0. So the first one from this network. And I will continue this with the for loop starting at 1. So this was the initialization of the outputs. So for the rest of these levels, I'm going to go until the end. And then the outputs is going to be overwritten by the new call to feed forward on the previously generated outputs and using this new level. So if this is confusing, then do watch the tutorial, because like that initial part explaining there about how the neurons work, and there are different things that I'm teaching in that one, quite scripted, and I just couldn't reproduce now something like that. It's a reason for that tutorial to be polished like that. It's better explained and has visualizations and so on. So I had to go faster here, otherwise this would take forever. So let's now go to our car and give it a brain. So I'm going to go here in the car, and where we are defining sensors to the car, I'm also going to define a brain. And let's give this brain a neural network, but let's make it simpler than in the other course. So brain is a new neural network using just the count of rays from the sensor. So this sensor ray count, and or let's try the same as in the course and then simplify it afterwards. So a hidden layer of 6 neurons and then the output of 4, because those are the 4 controls that we can add there. So now we should have a brain, and this brain part of the car, we can debug it. So car.brain. I really hope I have no mistakes here. So it seems to be fine. You are looking if this array length here is the same as this, because this is going to be where you pass the outputs of the first level is the inputs to the next level. So these two values must be the same. And then input is the 5 different rays here, and the output is the 4, which is going to be the controls. So this is going to be dynamic, like if we choose to change the sensor to something else, like 15 rays, then this brain is also going to change its properties. So the first level has on the input layer you have 15 neurons here. So right, I want to use this brain somehow connected to our car controls. So I'm going to go here inside of this. After we update our after our sensor is updated, I'm going to get the readings from here. And calculate the offsets. So I want to calculate the offset so that the closer the object is to the car, the higher the value between 0 and 1. So I'm going to write here the offsets are going to be the values coming from the readings. But I remind you, the reading has a x, y, and an offset, but the offset is actually opposite. Like it's going to be 1 at the tip of the ray. I don't want that. I want the offset. I want these offsets here, the neurons to light up more the closer the object is to the car. So I'm going to use here the map, and I will take each of these readings, and if it's null, that I'm just going to set it to 0. So if the sensor doesn't touch anything, goes all the way to the end, then there's a 0 value there. Otherwise, I will flip it. So 1 minus s dot offset there. And now I can calculate the outputs by calling the feed forward method of the neural network on these offsets like this, using the brain of the car. So we use this because it's a static method, so we have to pass the network itself. And let's just log the outputs like this. So I'm gonna refresh, and these are the outputs. In this case, 1, 0, 0, 0. But if I refresh multiple times, because these are randomly generated networks, they are going to change all the time. So, and they actually change also depending on these readings, like what the sensors are seeing. So you can see there, as I'm moving the car up and down, and the sensors are seeing different things, it may change the outputs. So these will mean forward, left, right, and reverse. if you press those keys or not. So that's what we are going to do next. We are going to make the car no longer controlled by that. Let me change also the sensors to have less of them, because I also want to visualize the network, and it's too complicated with 15 and not needed. There are too many of them. Less is easier to visualize more clearly. So in main, where we are defining this car to be controlled by the keys, I'm going to replace this with AI, like so. And in the car, I'm going to check here if the control type is AI. So I'm gonna set the brain is there. The brain exists no matter what the car is, unless it's some dummy that just goes up. So here I'm going to say, if we want to use the brain, is equal to, depends on the control type, if it's equal to AI or not. So if it's this situation, it means that we want to use the brain, because we have passed a control type equal to AI. And now this part from here, we are going to use to put these output values if we want to use the brain. So if the control type is going to be keys, we don't use the brain, and these are just calculated. It's like if somebody is paralyzed and the brain says do something, but the person doesn't move. So we will be in control then, but we still see what kind of suggestions the AI gives. So I'm going to write here, if we want to use the brain, then let's modify these controls so that forward is equal to outputs of 0, left is equal to the outputs of 1, right is equal to the outputs of 2, and reverse is equal to the outputs of 3. And somebody has pointed out, do these matter in which order we specified them? And no, it doesn't matter. But I am displaying them in the visualization so that we have forward, left, right, and reverse. To me, it made somehow more sense than some other order, like left, forward, reverse, right, or I don't know. So I just wanted this to match the visualization in some way. Okay, now this should work, I think. So if I'm going to save and refresh, the car just goes backwards. If I refresh again, it goes backwards. Nothing. Now it went forward and to the right. So something is now controlling the car, and it's not me. I'm using my right hand to click on the refresh, but these random brains are somehow triggering some kind of reflex action there. Okay, so I want to visualize the neural network. Before that, I'm gonna check quickly the comments. Four-way lane. Yeah, sure. You can change this to anything you want, but of course implementing it may not be trivial. I'm not gonna do it now. I'm a little bit behind schedule. If I want the car to do nothing, well, I think the car would do nothing if you... Yeah, I think the car would do nothing if the best car that we select after the fitness function is one that is not damaged. So if the fitness function considers this damaged aspect, then let's say you have a blockade in front, and if the fitness function is so that the one that goes the furthest up is the best car, then the one that will go furthest up and stop just before the blockade, that will be the best car. So it then does nothing because it stops as far as possible. So I'm not sure if this is a good answer or not. Control the speed. This is important because if the blockade is a wall, then this wouldn't matter. But if the blockade is cars moving and they are going to be moving at different rates, like maybe sometimes the blockade is faster, sometimes the blockade is slower, then you need to have that information of how fast you're approaching the blockade. And this is something we haven't tried yet. And I think what you're suggesting is really good. So another, not an output layer necessarily, but an input, another input node to the network that says your speed, or maybe the relative speed coming from the sensor. So we should update the sensors to not tell us just how far something is, but also how fast that thing is. Kind of like these police guns that check, like when police use the radar to see how fast the car is traveling. So it's not just the sensor that sees that the car is there, it's doing quick samples and checks how fast the car is approaching or speeding away. So sure, we could use the speed, but implementing it is not something I will do today. Sorry. It's too much trouble. Right. So visualizing the neural network next. Well, let's see. In the index HTML, I'm going to copy this, my canvas. I rename it to car canvas. So this is the same thing that we have at the moment. And the new canvas, network canvas, this is going to be the neural network next to it. So the car canvas here, I really need to do these changes, this refactoring step. So here my canvas goes to car canvas, and let's have the neural network, the network canvas, turn into black. I use black as the background. And then I think in main.js, I need to look up here and say my canvas needs to be refactored to car canvas. So maybe I can use rename symbol here. Car canvas, like this. And let's rename the context also to car context, like this. And then I think the network canvas needs to appear here as well. So I'm going to copy these with the network canvas, like so. And I think I can use 300 here because the width of this screen is 500. So now I have 400 plus 200 plus 300. Or if I want to have buttons in the middle, then let's make it less. I think I had a different screen set up in the other tutorial this one has 500 and it's not enough. Okay, too many changes today. But yeah, so the network canvas is gonna be here. And I want to set this height also, reset it as I resize the page. And yeah, that's pretty much it. So what I want to do next is this prepare the visualizing code. So here at the end, I'm going to say that I want to show the car brain on using this network context. So we need to implement this visualizer class, but let's say draw network, the car brain on the network context like this. And I'm going to add here the visualizer.js file. And I forgot to, let's add it here, visualizer.js. And now we want to draw the network. So implement the class, the visualizer class, and the draw network function is going to take a context and the network is a parameter. And I'm copying it from the course. I think it's explained really well there, and I'm running out of time. So the margin, it uses a margin there, 50 pixels, and these helper variables for left top, and then the width that considers the canvas width minus the margin times 2, because we are using already margin on one side and we want the width to consider the margin on the other side as well. So height here, also the canvas height minus margin times 2. And we will focus on one level first. So let's draw the first level. So I'm passing here levels of 0, and I will use where to draw this level. So left top, width height. So now this draw network function is going to draw only the first level for now. And let's implement this draw level. So given a context and the level information of the first level, and the left top. Yeah, width and height. So helper variables, let's have right is equal to left plus width. So I want to know what the right side of this is. We are gonna use lerp pretty much. And then bottom, we have the top already. And now I want a value for this radius, 18. And let's draw the input layer. So going through the level inputs like this, I'm going to calculate an x value in the same way we did for the road lanes. So the x is going to be linear interpolation between left, right, and then we have to do that check, like if it's gonna be 1 or not. So if it's gonna be 1, I just put this node in the middle of the screen, like 0.5 there, the offset. Otherwise, I can do I divided by the input's length. So this input's length, if it's really going to be 1, then 1 minus 1 is 0, and that's the thing that we need to avoid here. So begin path, arc at x, and this bottom location that we use for the input layer. And I'm going to use the node radius and then 0 math pi times 2. So this is for drawing a full circle. And we'll have these white for now. And fill. Right, let me close everything here. And I will copy this. So we should copy this so that I can draw the other output layer as well. But before that, maybe I test this code because I have a feeling I made some mistakes here. So network CTX is not defined. Of course. So network canvas, this network CTX, it's passed here. Wow, I'm amazed it works. So it does seem to work. There are 1, 2, 3, 4, 5 input nodes here at the bottom of this network canvas. A little bit cramped. I don't like it. I think I will try to have the thing have 300 pixels here. What happened? Why is this not working? Ah, okay. The network canvas is beneath. Somehow it doesn't fit exactly there. There's probably some kind of border spacing or whatever. Let me put 298 or something like this. Yeah, there's this spacing here. Let me see if I can remove this. No. I'm not sure why this is not immediately touching that. Yeah, and I'm somehow getting really tired. I'm not gonna bother with it. But if somebody knows, then that's great. Okay. Yeah, this is good. I like the spread happening there. So I'm going to go back to the visualizer and I'm gonna copy this code for the outputs. So let's do that. And have here outputs. Now these outputs go pretty much everywhere, but I really don't like this. So this code here is not good. It's it should be something extracted as a function, so getting these x coordinates of the nodes. In the original, I extracted it as a separate function. So I will do that here as well. So let me just replace this with visualizer, and it's gonna be a private method here. So get node x, and I will pass level inputs, and then I need to pass here left and right. So this is going to be a helper function that lets me write this in a nicer way, and I don't have to have this ugly piece of code there. So this is with the outputs. And one more thing that I don't like is that I'm repeating this level everywhere. So I could use here object destructuring, and I did that in the course as well. So I'm gonna say define inputs and outputs to be equal to level. So this is gonna extract the inputs and the outputs from the level. And now I can just type inputs and outputs everywhere like this. So the code is becoming a little bit easier in this way. So let's implement this private method here. And I'm going to say static get node x, and this is taking the nodes, the index, and left and right the intervals. And this just does the linear interpolation from previously. Should have copied this, but and 0.5 if it's like that, or index divided by the length of the nodes, like this. So let's close this, and this should work, I think. No, it doesn't work, because I should put the outputs at the top. Now it works. So outputs here at the top, this is the first level only. So here where we have the card defined to have this network going from the 5 inputs to the 6 outputs, it's just this part. So it's the first level only at this stage. And it's fine. Let's just work with this one for a while. And I'm going to now implement the connections. So I want to draw the connections between these, and I want them to be here. So let's say going through the inputs and going through the outputs. Begin the path, and let's move to the same function call from previously. I'm gonna use get node x of the inputs I left and right at the bottom, and line 2 at the top. But here I need to be careful to use this j, because j is iterating through the outputs, so not I like in these other cases. So line 2 visualizer get node x coordinate of the outputs of j with the left and right on the top. So let's put some styles here. Line width of 2, And I will just set this to orange to begin with. And stroke. So this is going to draw the lines in between these nodes. And I'm gonna move the code before drawing the actual nodes because I don't want to see those lines on top of the nodes. I want to make it look like the lines are coming out of the nodes. It's a little bit nicer like this. Yeah, padding of 0. Okay. I don't know. It doesn't seem to do the job. Don't remember. Maybe it was this. No, I really don't remember how that one worked, but it's just fine. Somehow these margins are something I don't encounter very often, and I don't know the solution for that. But these seem like they have no effect. It's anyway just fine. I can work with these. So back to our visualizer, we are going to work with the weights as well. So really here where we are drawing these colors, we want to be able to draw them different colors. So I'm using this blue for the negative weights, yellow for the positive weights. I like that kind of visualization. It's kind of like the sun is hot, it's yellow, blue, ice is blue. Or it's not really blue, but looks blue for whatever reasons. Sometimes, at least some kind of bluish tint. You can change them if you want, if something is more intuitive to you, of course. A red blue is also an option. It's used in thermometers. Yeah. Okay, so let's use the weights as well, and I'm gonna add them here in this destructuring assignment because I want to use them without typing level dot something. And here where we are setting the color, I'm really going to set it using this RGBA function. So I'm going to write here RGBA, and then let me do here concatenate with an R value. These are going to be constants we define just in a second. So G B alpha, and let me now close this. So, oh, too many of them. And here, let's take the value of the weight between this I and j. So I'm going to use a constant for that, like this. And the alpha value is going to be the opacity. So depending on how big this value is, the absolute value, because we have negative and positive, then that's going to be the alpha. And the red is going to be 0 or 255, depending on if the value is less than 0, then it's 0, otherwise 255. The green is going to be equal to the red. So this is where you could set the green, for example, to 0 if you want to have a red-blue spectrum. I'm not sure what I want to do here, so let's have a variation. Let's set it to 0 and see how it looks like. I haven't tried, actually. So B here is going to be the same thing, but in reverse. Yeah, and I think that's it. This should work. I'm gonna save and refresh, and it's a different kind of color scheme. I like the yellow more. Let me set the green to red, and now somehow I like it more. So this is fine, but we should start to draw also the biases and maybe extract this function as well. So let me extract this function first. So given a value, I want to output this RGBA style of a string, and I'm gonna go here in this utils and write this function down here. So let's call this function get RGBA with a value given as a parameter. So I'm going to do this alpha based on the value RGB and just return this RGBA string and close the curly brace. So back in the visualization here, I can now just call here get RGBA of the value, and all this other code is not needed. Actually, I can just pass here weights of I and j. So this code still works, but now I have one function call, and this is great because I'm going to draw the biases next. So let me add here the biases like this, and where we're drawing the output nodes here, maybe I do it like this. So begin path, let's say a line width of 2, and then an arc at the x and the top, so same as here, on the outside, and the stroke style. So this is going to be in the same way that we are doing here for the weights. That's why I extracted that as a function, because I'm using it multiple times. So here, the value of the bias of I, so the same bias of that. Okay. No, I forgot the stroke. Okay, so a little bit visible here, but not very much. Streaming computer closed again. Okay. So what should I change the display for it to work? I mean, okay. Anyway, I continue to style this, so I had a different style there in the course, and I think it was pretty nice. So, how did I do it? I actually don't remember. I think these were drawn twice with different radii. Yeah. So once black like this, if I remember right, and another one with the radius times 0.6, I think, and white. Yeah, something like that, but not white. This was get RGBA of the input value, inputs um, of I. So yeah, so now this is bright here because this sensor is touching it, and you can see what happens now. It's going backwards for some reason, but now these two are bright because both of these are touching there. And sometimes, like if something like this has happened, then these lights here reflect what happens here with the sensors. So this is great. I want to do the same thing here. So black, and then copy this again with the get RGBA of the outputs of I. And here where we are drawing the bias, okay, this is times 0.6 and this will be times 0.8. So I'm drawing the outputs so that the bias is this kind of circle around the other field circle that just says if this output neuron is on or off. Yeah, okay. So we're almost done. I still need to make it possible to display multiple levels there. And that one happens here at the top. So where we're drawing just the first level, this is really where I need to draw all of them. So I need to loop. And I start to first define the height of the level. So this is going to be depending on the height of the canvas and the number of levels. So the level height is going to be equal to height divided by network levels length. And now I'm going to loop through these like this. And let's use a helper variable here where each level starts relative to this top side, so the margin essentially. Linear interpolation. Yeah, so where it starts, it's at the height of this the value of the location where we subtract the margin from the height. Minus the level height. So yeah, I think this is correct. I just became so tired already that I can't explain this anymore. But basically from the bottom, but minus the level height, because this is where we are starting the drawing. So it's going to be the new, the top of each level. So we need the size of the height of the level here. And going from the bottom to the top, so to 0. And then this fractional value, again, maybe we have just one level there, so we need to check if that is the case and use half, otherwise divide by the levels minus 1. Right. So now we just draw the level. So the level from this, according to this I index, so ctx network.levels of I. And let me just put these down here. Left stays the same always. The level top is this thing that changes really. So that's what we computed. And the width and the level height also stayed the same. Right, and close the curly brace. Let's refresh. And now we're drawing everything. But it's not great because the biases here are hidden. When we start drawing from the bottom to the top, the next input layers are gonna have this black part here that is gonna cover the biases from the previous level, from the bottom level. So we actually need to draw this part here in reverse. So I'm going to start drawing from here, and then greater or equal to 0, and I minus minus. And this is going to leave the biases here visible. Great, it works. There would be some other things to do. I at least want to put here the arrows. So let me do that. And I'm gonna skip the dashed lines and the animation for this thing. It's I think overkill. So yeah. Oof, getting tired. So this draw level here, I really want to have a check. Like for the last level here, when we have I is equal to network levels length minus 1, I want to pass here some labels, some arrows to be drawn over them. So let me do the check here. So if I is equal to network levels length minus 1, then I'm gonna paste this from my notes here, because these arrows are some special characters I found online, and I don't remember the character codes to type them in. So let's have that there. And otherwise, this last parameter is going to be just an empty array here. So the last thing here is going to be these output labels. And only here where we draw the outputs, they are going to be needed. So we have to check if they are existing. So if for each of these outputs, yeah. Okay, so if the output labels of I exist, then let's begin a path, and we are gonna pretty much draw them as text, and I want this text to be centered horizontally and vertically as well. Then let's have a black fill, a white stroke, and the font size is something I really experimented a lot with, so I'm gonna use the resulting value here. Depending on the node radius times 1.5 and pixels Arial font. And then I'm gonna fill the text coming from these labels. So output labels of I at the X location and at the top, because these are drawn at the top. And now for the stroke. So if we leave it like this, then we won't see the arrow when it's drawn over a dark node. So I'm going to set a line width of 0.5 and then stroke text the output labels of I at X at the top. Okay, so what happens next? I'm going to refresh. I need a drink. So encoding of the file is wrong. I'm supposed to use here I don't know. I think I can use Ctrl-Shift-P and okay, change file encoding. Save with encoding. And this UTF-16 is probably gonna do the trick. Yes, it did it. But these arrows could be a little bit lower. I remember this was some issue. I add here some small value, like to the top. Let me put it on a new line. So plus node radius times 0.1. I'm doing these relative changes. Like now it's relative to the node radius because, okay, this works. Because if I want to ever change the node radius, like maybe to 14, for example, make them smaller, then everything still works. So when you work with relative values like this, your code is more robust. If you would just add here, I don't know, 2 pixels, then when you change sizes of things, if they're no longer relative, it means that your 2 pixel offset is not going to work anymore. It's going to be too much if we shrink these. I actually don't mind the new size. It's fun. It's good. Right. Ah, Mihai, salut. Maybe I check the chat a little more. Misha, that is a good idea. I think you're right. I think that this new line here and the spaces that happen are what's causing it. Yeah, thank you. Great. Now I don't have that thing to worry about. It was just a space. I mean, it was a blank character there. Or change display in style CSS. I forgot opening HTML tag. No, it's here. Majestic intro. Yes, very majestic. I had fun doing that intro a lot. It's a funny story. It's actually I've been humming that song. I don't know where I know it from. I don't think I invented that song, but I have no idea where it's from. I just always figure out that things that I think I come up with eventually mm, are from somewhere. I always um, I rarely think I invent something completely new. So that intro song, I was often like playing with my son when he was really small, like less than 1 year old, and swinging him around and singing. And I had this kind of tune there, always singing something like, and then I thought, I want to remember this tune. And I thought about making the lyrics to it and use it as a kind of corny intro song for some of my videos. And I did it. I invented those lyrics, which was kind of funny because then after that, when I was singing to my son or humming to my son, I'm basically singing to him my intro song, like already brainwashing him into watching my videos. um, so it's kind of it took the opposite turn. um, but yeah, it started off as that, and I gave it some lyrics because I just wanted to have a memory of this later on, and you guys seem to like it, even though I thought it's gonna be like, uh, I don't know. I've never sung anything before, and I don't know anything about singing. It was just a lucky thing. So that's the story about the song. Uh, yeah. Okay. Okay, but this is the same thing as opening the HTML tag. I mean, this is the opening the HTML tag, and just that's just notation. So yeah. Okay, and wow, I got greetings from Ukraine and donation. Thanks. I hope things are well over there. Hmm. Pretty much do the same thing. It's just if you remove this doc type from here, it's basically the same thing. But now your console will say that there is an issue here. So let me just put it back, and then the console says no issues. So yeah, I'm not gonna talk more about that. Okay, it's still not doing anything smart. Come on, a little bit more effort, and I'm sure I'm gonna get it to do something smart. I think I have to leave out drawing the car, unfortunately. But at least, how to say, mm, at least I have to do the optimization, right? So let's generate multiple cars here instead of this one car there. I'm gonna write a function for generating these cars. So function generate multiple cars given a number n. And these are going to be added to an array, an empty array to begin with, and going from 1 to n, I'm going to add here a new car. So these are going to be the clones, the kind of, how to say, those things that I try with multiple cars in parallel to optimize so that I don't refresh multiple times and spend forever. So let's put here all of them starting at the same 100 location, and then all of them will be AI cars. So I will return this cars array, and I'm going to have to add these to the top. So I will copy this function here, and the car will be generate cars of n. Let's say n is going to be 100 to begin with. And this is cars now, so I have multiple cars. That means I also have to change here this code, so I'm going to update all of them. I'm going to just do quick things like this, even though I don't think this is the best way to teach you stuff, because I'm just going all over the place. So that's why I typically type everything again and again, so you can focus on just one thing. But I'm tired. And yeah, this should work. So the same thing must happen for drawing them here. On the car context. Yeah. And we still have this car used in two places, like here when we do the offset, and here where we draw the brain of one of the cars. So I'm just going to replace this with the first car for now and just see if this works. So this is fine, I think. Maybe. Let's see. Refresh. Oh boy. Yeah. Too many things, too complicated. I don't need all those sensors. So let's draw these without the sensor. But let's have a sensor for these cars of 0, the first car, the one that we emphasize. So let's draw this one twice, once with the for loop and once without. And here we pass the sensor as well. So true. And in the car draw method, so draw sensor is equal to false by default, but because we tell that one car to have it, one of them will have the sensors. So I'm cleaning up a little bit, so not making a bunch of lines there overlapping. And I also want to emphasize this one car more, so I'm gonna make the other ones transparent. I liked this approach when I built the original tutorial. So here, when we are drawing these, I set this global alpha on car CTX 0.2, and then I set it back to 1 here. So what happens is that these are somewhat transparent, but the one here that is selected is going to be drawn with full opacity because it's being drawn again after this for loop. Now, only thing that really we need to do is find the best car. So this is where the fitness function goes. And we want to get the best car at each iteration, right? So it should go here after the traffic updates and after the cars update. So I'm going to write best car. And now I'm going to find the car that has the minimum Y value, because the Y value increases downwards. So the one that is the smallest is the best. And I will write a find the car. So let's have a shorthand variable name for this. So the Y value is going to be equal to the minimum of all the car Y values. So we need to use here the spread operator, because this min doesn't take array as parameter, it takes multiple parameters. And I'm going to extract here just the Y value of C, because cars are objects and the minimum of the object doesn't make sense. So I just do this. And I think that I'm done. I want to replace this best car everywhere where I have these cars of 0. I really hope I don't make a mistake here. So now the translation will happen so that the screen follows this best car. The best car is going to be drawn emphasized, and the neural network for that best car is going to be shown. And if I refresh, that's the best car. Now that's the best car. And so on. I do want to have ways to save these so that I don't lose the best car after each iteration. And this is where I'm going to use this local storage. So I'm going to store in local storage the best car's brain by just stringifying its properties into a JSON string and putting it in the local storage. So let me just go here and say, let's implement these functions. So save, and then local storage set item best brain. I just give it a name, and this will be JSON stringify best car brain. Oh, this best car needs to be a global variable. And let's also have a way to clear this information. So I'm going to remove item the best brain if we call this other function like this. So let me actually make this best car as a global variable. I will remove the const from there, and sure, I will say best car. It's gonna be let because it's gonna change. So this is going to be by default the first car. All of them are going to be generated at the same place anyway, so it doesn't matter. But if there is something in local storage in this best brain field, then I'm going to set the best car's brain to be whatever is in that field, but I have to parse it from the JSON string into an object. Yes, so now this could work. But I also had interface in these in that tutorial. Yeah. I think I'm going to give up on the interface. So, great. My streaming computer decided to shut down. I will take a little bit of a break and continue with this without the interface. I'm just going to debug in the console. And so no controls for saving and discarding the brains. But that's something quite easy. I just don't have patience anymore. So let me restart this computer. Right. So how am I going to test? I'm basically going to test like this. So if I want to save the car, this one, I'm going to call here save in the console. And now local storage. I have some weird things in local storage. Let me try again. So save. Now this looks fine. I think I probably tested something with local storage previously and it had another field there, but now it's just the best brain. So I'm gonna just call save here, and when I refresh, that car should still be there because it's coming from local storage. And every time I'm gonna get something better, I am going to call save in the console. So a little bit of okay, this I have to save. Wow, it did something. Okay, great. So it's working. I seem to have every time this this car saved, and then new ones are being generated randomly. So when we are starting here, I am giving the brain of one car the thing that has been saved previously. But I want to generate cars that are similar to that good one, not just completely random, because then I increase the probability to get something good, something that works. So the last thing that I'm going to do is the mutation. Yeah. So here in the neural network class, I'm going to define another function for mutating, another static function. So mutate, and given a network, because these are static functions, I'm going to give an amount, how much I want to mutate from the given network. And by default, I'm just going to set this to be 100%. And now I'm going to go through all the levels. Let's use the for each loop. And each level is going to go so that we change the biases and we change the weights according to the current value and this amount. So I'm going to loop through all the biases. Yeah, could have used another for each, but this is just fine. So each bias is going to be linearly interpolating between the current value of the bias, so whatever the current value is, and a random value between -1 and 1. So scaling 0, 1 to 0, 2, and then -1 gives us between -1 and 1. And I'm going to use the amount here. So if this amount is 1, essentially where I'm interpolating to is random. But if this is closer to 0, then I'm closer to the original value. And I'm going to do this as well for the weights, but here I need to use 2 for loops. So let's go to the length of the weights like this, and then for the ith weight, I'm going to go like this. And the weight of I and j is going to be equal to linear interpolation of the current value of I and j and a random value between -1 and 1. And again, using this amount. Wow, so many things to close here. Okay, so now I still need to do something with this mutation. So what I'm going to do is go back into main and here I want to mutate. I want to set all the cars to this best brain. So yeah, so let's do it like this, going through all the cars. I'm going to say the ith car's brain is going to be the best brain. So all of them are going to be set to this best brain. And this should work. So now what's happening is that this is not one car, it's all of them, all of the 100 cars, but they are all just wired the same way. So I want to mutate them. And I'm going to do that by saying here neural network dot mutate the ith car's brain with the value, a smaller value, maybe 0.1. And if I save this and refresh, now you can see the cars are not so random as before. They are more alike, so to speak. But if you do increase this value, like put it to 0.8, you are gonna get more randomness. So they are all kind of individual cars there. I kind of liked the 0.1 value. There's one more thing I have to do is keep one car unmutated. If I really want to make sure I don't accidentally save a worse car than previously, then maybe we say here if I is greater than 0, then mutate. So otherwise it's possible that I'm losing the good car from previously. So that's it. I'm now just going to play a little bit with this and hope that somehow some car is going to be better and maybe pass this car in traffic, this tank in traffic. I have no idea if this scenario is too hard. It kind of looks like that other car in traffic is causing a lot of problems. Let's maybe increase the number of samples here, and I think this mutation value is too low. Okay, this starts to be demanding on my computer and it's lagging. I hope the stream won't be affected by it. Okay, something is happening. I'm definitely going to save that one. And let's put less cars here. I could optimize this code much better. I think one of the reasons why it's so slow is because of so many segments here used to define the curve in the road. But I could use some kind of bounding box check or a solution for that. I just don't have energy to do that. So let's see next what happens. Come on. No, 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 no. Okay, okay. This is still doing something. Yes, 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 yes. Yes, yes. No, no. Stupid car. But it's better than nothing. So let's try again. Maybe 200, my computer starts to act up. Like too many cars in the simulation, and this checking the damage and the sensors, I believe it's a little bit too much. It needs some optimization here. I'm not sure what's happening here. It's somehow scared to follow along. I can't believe this. Alex Shifpopo. Loli. Salut. M-ați îmbogățit. You're making me rich. All right, let's save this one and refresh. I want now the cars to somehow develop a little bit more like confidence to try to pass that. It did it. Okay, we did it. So it's here. I have it. I saved it. It's now going forward, but it doesn't look like it's moving much because these lines there don't have the dashed lines anymore. I mean, the dashed lines were really there so that you recognize movement. It is moving, it's going up. But when there's nothing to see creating the illusion of movement, it just looks like it's standing still. Can I actually put back the dashed lines maybe for the borders? Okay, this also has some serious slowdown issues now. Hmm. Now I'm reading the chat at the same time and laughing on Alexandru's comment. Mhm. Okay. Well, at least now it shows like movement there, and I already have the car that I'm looking for. So that's it pretty much. These dashed lines are making the interface even slower. Let's have just 10 cars going in parallel. Even 10 cars are so slow. I really think that one car. So this is the saved car, and it should be much faster than this. Really, the drawing the road with these dashed lines is so slow. Yeah. So hmm, interesting. It seems to be slow when we are drawing polylines. So somehow I guess we can just live without dashed lines there. Yeah, so this is the end result. I think we can get much better card than this. Now it's kind of it's doing a lot of weird stuff, a lot of stopping and waiting. Like I'm not controlling it. It's just the AI deciding it needs to stop and wait for the other car to get out of the way, pretty much. So I'm happy with this. It's a new result with this curved road, and let me just try to, yeah, um, the cars that I'm generating here. So let me just put keys back on so I control this car, and let me see how hard it is to do this task. So okay, like I'm controlling the car now. I just want to see, can I pass this level? And I can't do it. It's not a big problem, but it. So it's not that challenging. I can pass this level. Uh, I can't pass this. um, I'm sure I can pass this level. It's almost there. But I'm also waiting for the other car, kind of similar as the AI is, because I don't have the courage to pass it um, ahead of time. So let's put back the AI and see again what it's doing. It's also doing kind of like me. So waiting, waiting, waiting again, and then here where this straight road is, it's doing it well. Okay, so about these dashed lines, I suspect the reason for the slowness is actually again the infinity constant. I don't know for sure. Let's have a look. If we lower this value and reintroduce those dashed lines, it could be also just because um, there are many segments now that we are drawing there, not just one long dashed line. But yeah, it looks like the infinity constant, lowering that one did the trick. So apparently just drawing many dashed lines and long dashed lines is the problem. And now you can still see the car moving, so it's nice. Okay, let me do a little bit more experimentation when in parallel. So maybe 100 cars. Yeah, so I'm just gonna do this and see if we get some better results while I check your comments and I get ready to go home. Because if I don't leave this place in the next 28 minutes, the alarm is gonna start. So I'm not gonna be here longer than 10 to 15 more minutes. So yeah, um, let me just refresh this from time to time and check some comments here. So mhm. I think that declaration for the doc type is part of the HTML opening tag. Um, I'm actually, you might be right. Yeah, I've never thought about this, and I just, hmm, let's add it here. It could be that you are correct, but yeah, well, result is pretty much the same because I think these modern browsers nowadays they they add it there if it's not there. So yeah, thanks for that. I've never really thought about it that much. Hmm. Then a lot of thank yous. The best brain, shouldn't it be in the mutate function somewhere? Yeah, I guess this was explained at some point because you said ah. How do you know how many hidden layers and nodes to have? You don't really. So it's kind of a guess, but in general, when you try to optimize a network, if it doesn't seem to solve the problem, then you need more of them. So I recommend starting off with few values, and then if it doesn't optimize, add more, but then optimization will take longer, especially with this kind of trial and error approach. But here, I'm quite confident that we can solve this with with no hidden layer. So what I'm gonna do now is remove the hidden layer and restart this. But this is, by the way, one thing that I haven't taught you. I removed the hidden layer, but it's still here. So some people have issues with this. You say at the end of the tutorial I made, if you change the structure of the network, it's not going to affect anymore because it's loading the network from local storage. So the one in local storage is the previously saved network. And then it's mutating that one. So even if your code here is now supposed to use a simpler network, it's still loading that one from local storage. So if I call the discard function and I lost that good car from previously, then if I refresh, this new structure is simpler. And now it works. So this is something I'm not very happy about because it doesn't let you experiment in a nice, neat way. And it also could give you some false understanding of things. Hmm. Yeah, but let's save now this new crappy car and try to mutate these using a simpler network. Doesn't seem to work. I think I'm gonna increase a little bit this mutation amount. Let's save from time to time. Okay, something better already. So it really depends on the difficulty of the task. Same as in biological networks. The bigger the brain, the more advanced things the creature can do. Same as here, but optimization should be much faster on smaller networks, especially with this approach here. Now, there are some research papers, some approaches that automatically decide the number of hidden layers. Okay, this is done. It optimized it. It found a solution using this simpler network here. So you can check out that paper I pointed out, this NEAT. I forgot what it stands for, but something like neuroevolution, something probably topology, because the topology of the network adapting, or I'm not sure. But it's something that tries to figure out the structure of the network as well. And for this task, really, you don't need a very smart brain to solve it. And that's why the future version of this course, the part 2 of this course, it's going to be more demanding. I'm going to make the roads come from real road networks. I'm going to use OpenStreetMap, and you can make the car travel in your own neighborhood. And there, I think that I'm going to add also some things like traffic lights, or maybe pedestrian crossings or something. I really want to make this next simulation more demanding. And then we might need more sophisticated networks and maybe more sophisticated training algorithms for them. So, yeah. Let's check this a little bit more, the chat. Yeah, this car that is going through the edges. So I didn't bother making some smart dummy car. And it's kind of like a tank that just goes through everything. It's still a valid obstacle in this case. I mean, it caused a lot of difficulties for this car. If I remove this car in traffic, I think that let's just keep one car here. So if there's no car in traffic, then this seems to be no problem at all. But with the car in traffic, then this AI has to do all kind of pauses and waitings, and it's waiting for it and so on. Yes, Tommy, I am from Romania. I I moved to Finland some maybe 11 years ago, but I am from Romania, and some of the people here are from there as well. Okay, non-dashed and add some other cars in front. Sure, I can do that, but I have to leave soon. So I'm not. And I will put this code somewhere on the GitHub, the probably the same Git that I used for the original tutorial. Let's see, I will keep you posted. Wow, this is something interesting. The car actually crashes at the end because probably, yeah, probably these sensors are mm, not seeing anything anymore, and for some reason the car wants to turn right. So it thinks there are no more obstacles. It's and then this one comes. Okay, funny. Um, yeah. Then, mhm. So problem with the dashed lines, I think it's just that it's trying to render that infinitely long road. So now that it's shorter, it's doing less processing. I have no idea how it's implemented in practice, but drawing lines is it's not easy. Mm, I'm saying in these courses that I don't use libraries, but of course I use some built-in elements. And drawing a line, it's you have the start point, the end point, and you have to interpolate the points in between. You also have to do this anti-aliasing, so the line looks nice when it's not like choppy in going in diagonal. So a lot of things like this are done behind the hood, even if I'm calling something simple like draw line or draw dashed line. There's a lot of work going underneath, and well, mathematical libraries as well. I'm using the math library there. I'm not re-implementing my own sine function or cosine function. Uh, those work using this Taylor Taylor series to approximate the values after expanding it. So when I say no libraries, it's kind of a lie. It's in a way an attempt to get more people to view it, but of course, many people understand that it just means I don't use some code that belongs to some complex package that I have to download and put into my system and so on. Okay. Uh, yeah, I think that this stream should go on my channel automatically when I stop streaming. I hope, because I'm not recording it here. YouTube used to work like that. It only deleted my coding ultra marathon, which was 24 hours straight because there was some time limit of 12 hours. So after I did that, I had to re-upload it. Luckily, I recorded that one. Um, Insights on how to make progress in JavaScript programming. Well, I don't know. I think that the best way to get better at programming is to program something you really want to have, something you really want to get done. And the motivation to get it done is what's gonna make you progress. You're gonna search for answers, you're gonna remember those answers, and yeah, I think just work on things you're interested in. If you're a student, then you have that opportunity to do those things. Mhm. When real work starts, then you're kind of um, limited to the tasks you get from there, and they may not advance your JavaScript as much as other things do. Yeah, about donating things, you really don't have to. So I don't do this for money really. It's more of a hobby thing. And about next time I'm gonna be streaming, I have no idea when that happens. So I used to have more regular streams maybe 2 years ago, but recently I'm uh, tired. and have other things to do. And this is already exceptional because today I had work in the morning. So then at the end of my workday, I started streaming. And if I didn't have my notes for when I recorded the tutorial in the first place, I would have been in serious trouble. Like, I couldn't have gotten this far for sure. Yeah, Radu.js. Yeah, sure, why not? Okay. Um, that's it. I'm gonna stop streaming. I have to exit this place before the alarm comes. And thank you all for watching and see you guys.